So good morning everyone. On behalf of the Department of Industrial and Systems Engineering, IIT Kharagpur, I welcome you all to Iconia 2024. We are about to begin our inauguration ceremony. In this occasion, I would like to invite our patron, the Deputy Director of IIT Kharagpur, Professor Amit Patra, to the dais. Professor Patra, please. Come. Next, I would like to invite our chief guest, Padma Shri Professor Shankar K. Pal, President of ISI, to the dais. I invite our head of the department and organizing chair and convener of this event, Professor Jhareshwar Maiti, on the dais. I invite the convener of this event, Professor Mamata Jenamani, to the dais. So we will start the inauguration ceremony with a Saraswati Bandana presented by our scholars.
या कुंदेन्दु तुषार हार धवला या शुभ्र वस्त्रावृता या वीणा वरदण्ड मंडित करा या श्वेत पद्मासना या ब्रह्माच्युत शंकरा प्रभृतिभिः देवै सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमा आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदां जाड्यान्धकारापहां हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदां बुद्धिप्रदां शारदाम्.
Next, I would request the dignitaries on the dais to lamp the light to begin our conference Iconia 2024. I would also like to invite Professor P.K. Ray and Professor Bishwajit Mohanty in this occasion to for the lamp lighting ceremony. And also Dr. Babu. please come to the dais for the lamp lighting ceremony. So next, I would like to invite the department head of the Department of Industrial and Systems Engineering, Professor Dhareshwar Maiti, for the welcome address for Iconia 2024.
Good morning. So, welcome to Iconia 2024. Respected Professor Shankar Kumar Pal, Padma Shri, Bhatnagar Awadi, President of Indian Statistical Institute, our chief guest for this function, respected Professor Amit Patro, Deputy Director IIT Kharagpur, patron of this Iconia 2024, Professor Janamani, convener for this Iconia 2024, Dr. M.R.M. Babu, distinguished scientist from ASL DRDO Hyderabad, my senior colleagues of the dais, junior colleagues of the dais, dear participants, authors, guests, students, research scholars, staff, and others online as well as offline who are helping in this great occasion. It is my pleasure and privilege to be here and to inform you about the Department of Industrial and Systems Engineering as well as the International Conference on Industrial Engineering Analytics, ICONIA 2024. So I will begin with ICONIA and then I will tell you a little bit about the departments, particularly our department, Industrial and Systems Engineering. So we are celebrating the 50th years, although we crossed with 50th, it is 51st, but the year-long celebration is going on, and this international conference is a part of this 50th year of celebration. So you can imagine that we crossed so many years with, I can say, with pride and proud of having many distinguished alumnus who are in, who actually contributed to the society. So, as well as the Department of Industrial and Systems Engineering being one of the most sought after departments from the students, I can say joining point from you, both at the UG and PG level, and we are ever vibrant, dynamic department. So such a department will definitely organize different functions, and we used to do so. And in the 50th year of celebration, in where we started in last year, early in April, and then we have conducted a series of different functions and events. So ICONIA 2024 is one of the big events in this year. So why this ICONIA 2024? Particularly, if you see that the technological evolution, what have been taking place, and the last decades, what we have seen that there are lot of changes in the technologies and as well as in the production and of service systems, and industrial and systems engineering being a dynamic department, ever changing, adopting the best of the practices in its curriculum, so is going through this evaluation also. And then we thought that under this era, particularly this industry 4.0, 5.0 or society 5.0 era, so how the industrial systems, production systems, service systems are adopting these technologies, and finally they are basically giving the service as usual they have given earlier. So we thought that one conference is immediately needed, and that should be an international conference where the experts from different fields will present their papers. There will be several keynotes and also other discussions and interactions in this regard. As a result of this, our department decided on 6 tracks in this particular conference. One is operation research and data analytics. Second track is operations management. Third one is process, product excellence and quality management. Then manufacturing and service sciences, human factors, ergonomics and safety engineering, and e-business and information systems. So we are happy to tell you that we got over 200 submissions in this particular conference, and we have our own that peer review process, which basically practiced in most of the international conferences of repute. And finally, we have shortlisted 118 submissions for presentations. These are from paper presentation point of view. And in addition, there are several keynotes, and I am sure that the participants, both online and offline, you will be extremely benefited out of those presentations. And I am sure that there are track-wise a good number of submissions that also you will see. So, regarding the conference, I can say that the funding also we got from different organizations, including GAIL and WCL, SK Traders, and we also got support from different IT academic as well as administrative units of IIT Kharagpur, and as well as beyond IIT Kharagpur. So you will be experiencing that the papers what will be presented, it is not only that from India, it is from abroad also, and you will also find out that papers are not only from IIT Kharagpur or IIT system, it is from across the countries, different academic institutions like NITs, state universities, including both public and private sectors organizations. So it's a good mix, and I'm sure you all will be extremely happy with this conference. Conference being the hybrid mode, definitely we found that more inclination on online from the presentation point of view, but for this particular conference, it is 50-50, whatever I understood from the people. And about the department, I want to tell you that, see, Industrial and Systems Engineering has crossed its 50th years successfully. So we have changed our academic curriculum and the program accordingly. Particularly this year, we are introducing a new MTech program, which is in Operation Research and Data Analytics. So it will be started from this autumn 2024. In addition, department also preparing another new MTech program on logistics and supply chain management, and keeping in view the current PM Gati Shakti and that logistic and supply chain requirement of the nations particularly, but obviously beyond the nation. But our original the running MTech program in industrial engineering management, this also will continue. And we have BTech, MTech, dual degree, masters, PhD, postdoc, MS, all programs. So participants, you may please go through our website and see that how we are doing it. Our faculty members are contributing to different research as well as practice-based solutions. So you will be happy to see all those things. So with this, I welcome all of you to this function, inaugural function, as well as for these 3 days Iconia 2024, and I'm sure you all will be happy and your stay will be fruitful in this campus. Thank you so much.
Thank you, Professor Maiti. Next, I would like to invite our patron, the Deputy Director of IIT Kharagpur, Professor Amit Patra, to come to stage and share his thoughts. Thank you.
Agane sparshamaning lagaya pranai jivanang pavaya jivanang pavaya jivanang pavaya jivanang pavaya dahanadhanai agane sparshamaning lagaya pranai. Let the touchstone of fire touch my life. Let my life become a bliss. Let my life become a bliss with the touch of the fire burning. So this is a translation of a Tagore song. In Bengali, it is Aguner Poroshmoni Chumao Prane. So recently I came across the Sanskrit version, so I could not resist, singing that, especially with the lit up lamps. And I think this creates a good backdrop for all that we do. Anything we do, we must purify our heart first before we embark on any activity, and it is fire which actually does it for us. It purifies everything. chief guest, Professor Shankar K. Pal, Professor Maitri, Professor Janamani, all professors and colleagues on the days, other dignitaries on the off the days, and all the participants and the student friends. It's a great occasion and great timing for this conference because it is just between the you can say it's the onset of Vasanta. We just had Saraswati Puja 2 days back, so it is a very good time and the weather is beautiful and not too cold, not too hot, not yet hot. So it's a great occasion, and in particular I would like to give my respect to the chief guest, Professor Shankar K. Pal. That's how we know him. In fact, when we started our PhD almost 35 to 40 years back, we used to see a lot of papers by Professor Pal, and it used to be always Shankar K. Pal. So that's how we remember. No matter how else you write his name here, he will always be Professor Shankar K. Pal. And then later on, of course, you all know that he received many awards, including the Padma Shri. But he has been more than that. Actually, he has been a role model for us, all of us who had been following his works, especially in neural networks and signal processing. And so this has become a real inspiration for many of us. On behalf of IIT Kharagpur, I would like to welcome all of you today on this occasion, in this international conference. As you probably know, that IIT Kharagpur had started in 1951, so that is almost 75 years back, and we are soon going to start our Platinum Jubilee celebrations. So 75 years is a long time, and in 1951 itself, we had major departments set up, like mechanical engineering, civil engineering, electrical engineering, all the science departments. And within 1 or 2 years again we had agriculture engineering and several others. After that we had a steady run, and I think it was the next department to come up was industrial management, Department of Industrial Management, which was about 50 years back, and that is the 50-year celebrations we are having for the department. And then we had 1 or 2 more only, computer science and engineering, and now we have got a Department of Education. So IIT has come a long way over these 75 years. Apart from these departments, we had several other units and centers. Especially we had a School of Medical Science and Technology. We had the Vinod Gupta School of Management. We have the Rajiv Gandhi School of Intellectual Property Law. And we also have a Department of Architecture from the very beginning. And so that way IIT Kharagpur is now covering almost all facets of education. Architecture, law, and soon we are actually hoping to get the permission to start a medical program. So once we have that, IIT Kharagpur will become almost like a university. As the current naming convention goes, it's like a MERU, Multi-Education Research University. So somehow, we also have our own doubts and internal discussions whether it is good or it is bad. But I think the nation wants certain things from the institutes, especially those which were set up soon after independence, and we have to really introspect and see whether we have been able to deliver those. Certain things we have delivered in the sense that we have delivered manpower. We have educated a lot of students, especially the initial undergraduate students. They became the brand ambassadors for us. And later on, I think these days we are also trying to make a mark with our research programs. But even given all that, we are still, if somebody asks us, what have you done for society? We don't have a very quick answer. Because, of course, we can always do a blame game saying that, you did not do your part, so we could not do our part. But at least we should be honest and truthful and decide, internally whether we have done our bit, whatever we could do. And suppose we needed something else from somebody else, like a government or whoever. So did we go out and ask them, and did they say no? If they deny it, of course we can't do certain things. But if we can, if we have to really expand, and if you have to compete with some of the likes of, if not Harvard and MIT overnight, but at least some of the top universities in the world, at least to be within the top 100, let us say, at least top 150 to 100. And although again there is a lot of debate, this ranking. So the ranking per se, probably the number that we get need not be taken or may be taken with a pinch of salt. But within the ranking itself, there are a lot of factual parameters, like teachers to student ratio. So as all of you know that the teacher student ratio which was envisaged for the IITs when it was set up, it was 1:10. That is, for every student, for every faculty, or for every 10 students there should be one faculty, right? Now even now we are really very much off. In fact, initially we had that ratio, but now it is no longer so. With IIT Kharagpur having about 17,000 students, we just have about 800 faculty. So it is even worse than 20:1. So here, these are some factual things, and I'm sure all of you will realize that if we don't have these numbers, then we are really not able to give that much to our students, because every student is getting 5% of our time rather than what they are expected to get is about 10% of our time. So we have to see, and keeping in mind also the best practices all over the world, I think we should try to improve and try to give something back to the society that has nurtured us, and I think it is all of our responsibility. And I request even those who are participating in this conference to also introspect and think about whenever we are doing some research, are we really seeing the big picture? In fact, one of the good things about the industrial engineering department, in fact the department changed its name to industrial and systems engineering. And I feel, reading through the papers that have been submitted and getting presented here, I think this department's name could be more like an integration engineering, right? So what happens is that many engineering branches, like say electrical, which is my field, we build devices, small things, one motor, one battery pack or something like that. But when you really need to make it useful, you need to have many more interactions and integrations. If you are, if you talk about a car factory, car manufacturers, they hardly manufacture anything. They basically assemble. They get it from different sources. They standardize the items, but then they get it from the car ancillary companies. And it is the integration which makes the car. So design and integration. So I think that is a very important thing, and I can see from the papers that you have looked at different aspects of industry, and I think it is beyond industry. It is we are even today talking about I saw some papers on security of data and things like that, and use of large language models. So it has to change with the needs of the society. Today the education as well as the research, it's all changing with the advent of this large language model, so-called chat GPT and things like that. And we have to tune ourselves accordingly with the changing times. We have to see how we can avoid being, how our students should not misuse the availability of ChatGPT like things, but we should see how we can synergize, take it along with us. So just like when a video recording came, many people thought that it is the end of teaching, but that was not the case. We all know that just recording a video and putting it, uploading it in the web does not make anybody educated, because you have to create the whole, the context, and there are also things beyond just the teaching or the derivation of an equation. There are these the intangible things, and one may be able to solve a problem, but when it comes to formulating a problem, you will come across that it is not so easy, because you have to make a lot of assumptions and many things you will not know, and that's what, and I think that is where we have to really move ourselves as teachers. We have to take ourselves away from the solving of given problems to how to formulate problems and how to approach a problem, and that way you have to educate the next generation of students. These are some of my thoughts, and I don't want to take any more of your time. So I wish you a very good stay in the campus, those who have come physically, and those who are online, good health, and wish you all have good weather, because not everybody is as fortunate as IIT Kharagpur today to have this kind of nice weather. Thank you very much.
Next, I would like to invite our chief guest, Padma Shri Professor Shankar K. Pal, to come and share his thoughts.
Dear Professor Amit Patro, Deputy Director, IT Kharagpur, Professor Jhareshwar Maitri, whom I know since 2017, 2016, okay. Then Professor Mamata Jenamori. They are the first name you cannot forget in Bengal. Every day in the newspaper you see her first name. So it's just very, very good morning to all of you, including those who are up there. It's my great pleasure to be present in this holy occasion when the Department of Industrial Engineering and Industrial and System Engineering, they are organizing their Golden Jubilee celebration for 1 year long celebration. And just I was told that this is the last event, international conference on system engineering and analytics, industrial engineering analytics. See, industry, I'm not associated with industry, I'm involved with system. Whenever we used to write paper in write every transaction, it's also write the system stocks, like system analysis, system performance. Do not say the machine performance. So the system is a very general word. We always, it represents human being, it represents machine, it represents everything. So a system. And I come here because of the conference. There is a word called analytics. So there I have some connection, because the work I have been doing, people say I am doing AI. I do not know whether I am talking AI. When I started working in pattern recognition back in 1975, that time nobody knew what is pattern recognition, no book, nothing, etc. And I passed from famous Institute of Dedication Electronics, who have built this electronics and communication department here, stalwarts. They did not like our activity. Then I was, after 10 years, when we returned from Imperial College, I was told that you belong to computer science. And then some hardcore computer science people say, no, you are not computer science. But then they cannot throw it at us because our subjects are bringing money. Now I see that people are calling me artificial intelligence. So anyway, so that's the link I have got. Now the system engineering department, as Professor Jhareshwar Maitri said, I first attended a research scholar day. That was a unique event I have heard. Or wherever I have worked in world, in overseas or in my country, I haven't heard this word. And that's how we started our collaboration. And that's a really holy collaboration in the sense. It's not a syndicate business. Just like you see that now the paper, in the name of collaboration, you have got 5 authors, 6 authors. Everybody is increasing their parameter H index. It's not that collaboration. His expertise in system engineering, quality control. I had little experience in pattern recognition, image processing, and some neural network tools, and some little. So they think that I will be useful. That's how we started collaboration. We had a joint PhD student also, Nima. She has submitted her thesis in 2023 May, but result is not yet. I did not expect it from an IIT institute. Say 9 months, one report is not coming. But anyway, that's how our collaboration started. I'm very happy that we could publish many good journal IEEE transaction papers with his team. Now, if you look at this AI, now it's a buzzword. It's a Americans give every 10 years one buzzword, and we all Indian, Chinese run after this. So postdoc, pre-doc, and our governments also. I have been telling everywhere, it's good to have some subjects are, all subjects are good, some subjects are more good for some certain time. But at the same time, I will say, any excessive talk on a topic by not allowing the growth of other disciplines may not be always good, as it affects the overall progress of science, which is very much required for the benefit of society and mankind. So that's what I'm telling for the since 2015-16 where we are going. Today I will also mention in my keynote talk. In a keynote talk I will give you my 50 years journey, starting from pattern recognition to today data science, how the subject has evolved. With these few words I'll conclude. I wish the department to have a healthy survival. It's not a such survival, it's a healthy survival with all glorious achievements. At least I may not be living when the department will be celebrating platinum jubilee or even diamond jubilee. But I wish my all the bestest wishes to Professor Maiti and his many other colleagues whom I know, Professor Rai, and I'm seeing them one, and all beloved students, for their glorious survival with all international recognition, and etc. Thank you very much. Thank you. Thank you.
Thank you, sir. In fact, let me tell you, sir, actually, it's because it's quality control issue from our actually all of you please know that system is capable, but sometimes what happens due to maybe some ascertainable causes, some outliers are there. I think our PhD program is very good, and it doesn't take so much of time, but it again talks about that yes, there are some outliers. I hope that things will be set right, and yes, actually I came even when Professor didn't call me, because we had a really great collaboration with Professor Pal. So that I want to tell you again, because earlier time when I was doing research, I was always being a little bit afraid of targeting the one of the topmost journal in this particular domain. Then when I met Professor Pal, he said, no, you are doing wrong thing. You have potential, you do it. Then I said, okay, so let us start. And ultimately, perhaps in this particular, the first paper what you have published with him, probably in that domain it is probably one of the top journal. So I am extremely thankful to you, sir, just for giving us this kind of courage and confidence. And in a follow suit, I say that a lot of other good journal papers we published because of his association. So I want to show my tribute to you, sir, and thank you so much. Thank you.
Next, I would like to invite Professor Mamata Jinabani for the vote of thanks.
Good morning, everyone. So now we are at the end of this inaugural ceremony, and it's a great opportunity for me to tell the vote of thanks for all the helps that we have received from every source. To start with, we are extremely happy to have Professor Patra, our Deputy Director over here. In spite of his busy schedule, he has spent some time with us. Thank you, sir. And we are extremely grateful to our chief guest, Padma Shri Professor Shankar Pal, President ISI Kolkata. And you have already heard his long association with us, and we are very grateful, sir. And we are eager to hear you for your keynote speech. We are thankful to all our senior faculty members, junior members, and team Professor Saik Raichaudhuri, who really worked hard to make it successful under the guidance of Professor Maiti, head of the department, who is the convener and organizing chair of this conference. And we are really thankful to our sponsors. Our diamond sponsor is GAIL, Gas Authority of India Limited, and specifically I would like to thank Dr. Jubraj, with whose help we could get the sponsorship. Then we are thankful to our silver sponsors, Western Coalfield Limited and SK Traders. All our keynote speakers who spared their valuable time to spend with us for the next 2 days to give their insights on various advanced fields. Then our scholars are our dark horses. They are not upfront coming, but they are everywhere. Without their support, things would not have been possible. Thank you, students. And our master students, and even I can find some of our first year master students who are, in spite of their exams, are still here. Thank you. And finally, our participants. Participants both online as well as offline, we are really grateful to you for your contributions, and we look forward. We look forward for your to see your presentations, and we are also grateful to our administration, both academic and non-academic administration, as well as all our staffs from CEP, and who are able to send this meeting as well as all our events online through Meet, as well as it is also happening, I think, through YouTube. Thank you, everyone.
So with this, we are at the end of the inauguration ceremony. We will come back here at 10:15 a.m. with the keynote address by Professor Shankar K. Pal. There is tea outside and a little bit of networking session. You can get to know each other. So thank you, everyone. Thank you, Professor Patra. Thank you, Professor Shankar K. Pal, and Professor Maiti and Professor Ejinaman. Thanks.
Hello. Hello.
Hello, hello.
ठीक है ना, यहाँ से देख पाएगा नहीं? उत्तम, टीवी और थोड़ा घूमेगा। लॉक खोलो और थोड़ा दम और थोड़ा मारो, बस ठीक है, छोड़ दो।
हेलो चेक, हेलो 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 चेक, हेलो चेक, हेलो 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 चेक, हेलो चेक, हेलो 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 चेक, हेलो
Hello, hello, hello. Pacho. Hello, hello, hello.
Good morning, everyone. We are now ready to start our keynote speeches, and our first speaker is Padma Shri Professor Shankar Kumar Pal. Professor Pal is a distinguished scientist and former director of Indian Statistical Institute. He founded its Machine Intelligence Unit and National Center for Soft Computing in Kolkata. He is a National Science Chair, ISI President, and Emeritus Professor. He is also AICT Distinguished Chair Professor. He obtained his PhD from Calcutta University and another PhD and DIC from Imperial College London. He worked at University of California, Berkeley, UMD College Park, NASA JSC, Houston, US Naval Research Laboratory, Washington DC. His award includes SS Watnagar Award, Padma Shri Award, G.D. Birla Award, O.P. Vasin Award, Jawaharlal Nehru Fellowship, FICCI Award, Vikram Sarabhai Award, IET Wadhwa Gold Medal, INSA Jahir Medal, ISP PC Mahalnobis Gold Medal, INAE Chair Professor Award, INSA Distinguished Professor Award, INAE SN Mitra Award, INSA JNBC Lecture, JC Bose National Fellowship Award, DAE Rajaraman Fellowship Award, and so on. Sir, the list is so long. If I read the whole list, probably I will take another 10 minutes or so. So, some of the awards and all I have just skipped. Sir, I welcome you. So, kindly please come.
Thank you, Professor Janamani. Does it work?
Yes.
Okay, thank you. Because many often I see that it doesn't work. Good morning. The talk that I have chosen in this gathering, that my experience over the last 50 years, I decided to speak it on this. I give the similar talk in Indian National Science Academy annual general meeting in Vizag last 2022 December. Pattern recognition, machine intelligence to deep learning and data science. Evolution, challenges and certain concerns today, particularly for beginners. As you see the topic, it covers a wide spectrum, and it will be my basically, you see, what's happening? See, now every time, so actually it's a journey over about a 50 years. Okay, now? Okay. Now the talk, I was told to complete in 45 minutes. So now that's why I have reduced my many slides last night. So I will explain what is pattern recognition in 1 or 2 slides. Many of you, I believe they know, but still in the context of my talk, I need to say a few words. And the challenging areas back in 1975, when I started working on 1st March 1975. Then why fuzzy set theory came into that picture, I will mention. Then around 1980, expert system came. That is another buzzwords. Buzzwords are given by Americans always. Because Americans love to give new names. It is statement made by Professor Lathvi Jade, University of California, Berkeley, when I was visiting him as Fulbright fellow. He said, "You Americans love to give new names. When I was a chairman of electrical engineering Berkeley, we decided to give a new name for computer science. So we called MIT electrical engineering chairman, we give. Now SK, you are doing pattern recognition. Pattern recognition has certain limitation because it takes some certain measurements, the feature, that one. No, that's not the way our human mind works. So now it's a hot topic called expert system. So government funding everywhere, in IIT also, at my group they will be knowing medical expert system, law interpreter expert system, expert system, expert system. Then we had knowledge based system after 10 years again, sorry. Knowledge based system. Knowledge based system in India had 5 knowledge based centers. Indian Statistical Institute, Tata Institute of Fundamental Research, Indian Institute of Science, IIT Kanpur and CDAC Pune for 5-year program, which is an advanced form of expert system, expert in terms of intelligence. And that time AI and machine learning cropped up in 80s. But the subject could not survive because we did not have sufficient amount of data, processing power, availability of storage space, etc. So my institute also offered a course for 2 to 3 years in AI back in that 84, 85. But there was no job. So then every evolution, new technologies come. Soft computing cropped up. Then in 2010, called data mining because of the genome project and internet, www. Data become heterogeneous. Data characteristics have been changed. Therefore, statistical decision making is no longer applicable to them. Then we had that new topic called granular computing to mine large data sets. So every evolution, new technologies are evolving. Then 2000, we call big data, characterized by 4 V's: volume, veracity, velocity, and variety. Now, I will explain. Then today we are calling deep science, data science, deep learning. Without any topic, without lecture or data analytics, data science, whatever name you call, without deep learning, lecture is incomplete. Then I will explain the evolution at last and the concerns that are very important for beginners. Now, what is pattern recognition? As we had learned back in 1975, based on the concept of Professor K.S. Fu, electrical engineer from Purdue University. See, subjects were all evolved by electrical engineers. Then mathematicians jumped to develop the theory, etc. But need from electrical engineers. What is the need at that time? How to identify a crack in a bridge where you cannot reach. How to identify, how to communicate with the machine in your natural language, man-machine communication. That was our objective when we started working. K.S. Fu, but he has passed to a very early stage, 52. So it has 3 blocks. You take in any object, your certain measurement could be numerical, measurement could be non-numerical. For example, when you go to a doctor, you tell your problems in terms of linguistic terms, low, medium, high. So out of those, you discard something which are not required because it will increase the computational burden and also improves and enhances the ambiguity in decision making. Unnecessary features, unnecessary attributes should be always discarded because the objective is to increase the separation between classes or concepts and you reduce the separation within classes. That means inter-class separability and intra-class separability. Then you make a decision. And here uncertainty arises from deficiency of information available. We cannot remove, but we can reduce uncertainty. And it comes from ill-definedness, vagueness, so many things. And then in later on became image processing, the image is very expensive. So image became a pattern, then itself has some processing task. Enhancement, edge detection, cleaning, filtering. So then we have a new topic called image processing, which came out on it by its own right. But objective is making decision about the institute. So you call low-level vision, mid-level vision, high-level vision with an amount of overlapping. Now the major task, 3 tasks, I will explain for them. classification and clustering. And today feature selection because of the big data. Previously feature selection was not that important, but today it's the one. So in the clustering and classification, what are the challenges? In classification, you are giving some level sample. That means you know their origin, but you are asked to identify the remaining samples. So sample data, incomplete information given, and challenge is to estimate the unknown region. So that means you abstract information from level and then make it generalization. This basic two concepts you have to keep in mind for any kind of machine learning problem. And another one is clustering. So you are given the entire data, but no information about the class, no information about number of classes. But you are asked to segregate or partition them into meaningful homogeneous pocket. The word meaningful is subjective, therefore you can have many such solutions. That's why clustering is an unsolved problem. But it is a must for any data analyst. When we started working, that was subject for electrical engineer. But today, any data, because you are giving data over the whole day without knowing where it is coming from. Say satellite image ISRO is collecting. You do not know, but what you do? First you try to partition them as many as possible into homogeneous pocket. That's the beginning. So clustering is a must. So one you see that is called supervised learning, it's called unsupervised. So learning concept was back in 1975, but literature you go, it is 60s pattern recognition subject. I've checked with the Google search, it is 60s, but in India we started around late 60s. 3 institutes, again TIFR, Indian Statistical Institute and IIC. These are the 3 premier institutes in the country. Now, life is not that easy. This is a very simple problem. 2 class, 2 concept, linear separable. Similar shape, but different size. So you can hyperspherical data. Piecewise linear separation. Overlapping, hyperparabolic. So you get this kind of concept. Just I am giving typical example. So linear to highly non-linear boundary you need to generate. That's why you're getting so many classifiers, starting from minimum distance classifier to base classifier, and today neural network, fuzzy logic, genetic algorithm, so many. The objective is there how to get the boundaries as much as possible, get corrected within your money, within your capability. Now you see, what are the challenges that time when we started working? The classes are overlapping. How to minimize? That's the overlapping comes for because of this given the attributes. If you enhance another feature on another attribute, overlapping will be reduced. But given this one, because your camera has some limitation, your spectrogram has some limitation, so it comes overlapping. So overlapping was taken care of by probability theory, which is based on probability density function, that the number of times an event has occurred. And new technology came, fuzzy set theory. It's characterized by membership function, which is nothing by a concept of matching an object with an imprecise concept. It's a concept of similarity of an object with an imprecise concept. There is nothing called number of times it has occurred. So comparability of an object. Now it is characterized by membership functions are flexible because you play with them. That's why it becomes so reputed for flexible and uncertainty analysis in decision making and modeling linguistic input. That is low, medium, high, very low, etc. You can. That was its objective. That means the challenge was to bring a root relation of the abstract concept of fuzzy set as led by Professor Jade with pattern recognition image processing. He got maximum support from control theory from Japan. But there is another aspect where we spend life for making a generalization decision making, that be reducing uncertainty or managing uncertainty. So that gave rise concept of multi-class belonging of a pattern. That a pattern has a right to come from more than one class. Now look at this image, gray image. It is a sinusoidal variation of intensity. You cannot find the object region. So here the regions, boundaries, etc., they do not lend themselves to precise definition. So based on that, entire fuzzy image processing work started when I was working at Imperial College. That Professor Rosenfeld in Maryland and our group at Imperial. Even Imperial College didn't have that facility. After I joined, they arranged facilities for me. So these are our first paper from India. I did system and cybernetics for fuzzy set in speech recognition, and from Imperial College paper electronics letter, very prestigious journal who are in electrical science. They will be doing for IW publications. Very prestigious journal, pattern fuzzy set in image processing. Now, in 80s, we thought that pattern has some limitation because it takes some measurement, extract features, then you make a decision. But that's not way our human brain makes decision. So this gives rise to the concept of incorporate experts' opinion, that is intelligence into the system. So how? It's in the form of rule base. Just to, if you go to medical solicitor, if this is the one, then this is this. If this is the one, so we are trying to quantify. So it's called rule-based system. In the rule-based system, you use probability theory, the probability of transition from if and then, consequent and antecedent and consequence. Fuzzy logic came in the rule base. Then rough set theory incorporated, became another hot topic. Rough set was explained by an applied mathematician from Poland. It's a land of mathematicians. Uncertainty modeling. So new terms, rule base, rule learning, rule adaptation, retrieval, new terms coined. So every evolution came. And then it gave rise to the concept of artificial and machine intelligence. What is machine intelligence in lessons? Learning the data from examples, from experience, from previous knowledge, etc. So learning patterns from examples, machine learning. And this idea came based on the relation of Alan Turing back in 1947 when he gave a talk in London Mathematical Society that what we need a machine that can learn from experience. That's basically the concept of intelligent machine. So concept came in back in 1987, 1945-47 as per his work. This famous work, envision of intelligent machine. The machine that can mimic our human mind, brain, etc., that it will give you the best possible solution, best probable solution. This is the objective. But then, at the same time, neural network revived, 1980s. Professor Avit Patra was telling, yes, we picked up the subject without knowing in ISI and we published a lot of paper. So, artificial neural network revived, then genetic algorithm also came, and AI and ML became a hot topic that time, starting from 80s. And we have published so many papers, ITB transaction, and became associate editor of ITB transaction on neural network. This is the first time from India, from just some associate editor of an ITB transaction. But before that, it was very difficult to even publish full paper from India, and just forget about editorial board. But we had lack of adequate data. Sorry. It's a problem. Yeah, this side I am tracing. Forward.
No, this is the previous, this is the next.
Next, I am talking about.
The last one is the black button. This one, big button.
This one. Sorry. That means the 5 buttons. 2, 2, 1. So here lack of adequate data processing power and subject could not survive. But today we have abundant data, so machine learning is a meaningful choice. Now come to the one knowledge-based system in 1990. Because rule-based system, it has limitation, if then one. but we want to generate knowledge from the data, evolve data from knowledge using reasoning capability. So, use domain knowledge skill. So, use domain knowledge, and word knowledge base became a new word that time. Reasoning, derive new knowledge, incorporate higher level knowledge like semantic, syntactic, pragmatic in the rule base, so that to make the system more intelligent. And new terms like knowledge representation, case-based reasoning, new terms come. There is a book also available, research area. Information retrieval, rule learning, we are already in the expert system. The India had 5 knowledge centers I mentioned, and new technology came, soft computing, because it has flexibility, tractability, low cost solution, and human-like decision making. And it takes care of learning, uncertainty modeling, reasoning, searching, and speed. I will explain one. So, what is soft computing? In one slide, to exploit the tolerance for imprecision, uncertainty, partial truth, and likelihood, in order to achieve these 4 properties like tractability, robustness, low solution cost, and close decision. That means you find a approximately a solution to a precisely or defined problem. For example, when you make a parallel park, if you drive always, students. If you are in a metro city, you cannot do the parking. You have to do parallel parking. And I passed parallel driving in Houston, and first test they give for parallel parking, and I failed 2 times. One, parallel parking. What is the problem? You put your car exactly between 2 cars, and we are living 6 inches from the footpath. But if you know driving, it's a few minutes just. Why minutes? Because you are not solving the problem precisely. But because if you ask you to put your car exactly between 2 and leave it 6 inches from the footpath or car, then it will take hours of maneuvering. That means you are using exploiting the tolerance for imprecision. So this is what the basic concept of high precision carries high cost, and sometimes it is meaningless. And most of our big data analytics problem, we do not need precise solution. So its basic concepts are fuzzy logic, neural network, genetic algorithm. It takes algorithm uncertainty arising from overlapping concept, neural network for learning and curve fitting. It takes care of reasoning also, genetic algorithm for searching, and new technology we adopted, we introduced rough set, uncertainty arising from granularity. So it takes uncertainty from overlapping, it takes uncertainty from granularity, not probabilistic. If you take probability, it will be even higher. So within soft computing, they are not complementary. They do not fight with each other, but they help each other. And it was argued that soft computing is a backbone for modern artificial intelligence. Now, I will explain one example. Before that, I mentioned the synergistic integration of, that was one of the challenges. How to make synergistic integration of these tools in order to obtain application specific merit. What is application specific merit? That is the merit that you cannot get using the individual tools alone. That was our challenge. So accordingly, in the market, you have neurophagy computing is the most visible one. Neurophagy camcorder, neurophagy vacuum cleaner, neurophagy underground, everything we came. I will give an example of how the neural network has nonlinear boundary generation capability, fuzzy logic uncertainty modeling, how this can be integrated. But before that, I mentioned for those who are not aware of neural, because today we are talking about deep learning network, so you have to have the basic idea about shallow networks. So that's why I'm talking artificial neural network. So what are the basic characteristics of artificial neural network? Because as we moved after that, adaptivity, speed, fault tolerance, ruggedness, optimality. These are the characteristics any design engineer would love to have in his or her system. Adjust to change in information, that means when you go to a new place, you adapt yourself. Speed via massive parallelism, fault tolerance to missing, confusing, noise data, ruggedness to failure of components, optimality 1. And it became learns from example. That if you give if A then B, antecedent, consecutive, and consecutive, it has a capability of learning the relation, whatever complicated it is, and stored the parameters in its network parameters. So that's why it became a very ideal tool for machine learning. So machine learning cropped up in 80s, artificial neural network joined, revived suddenly. So AI machine learning was a hot topic that time, 80s. That's why. This is an example which received that IEEE Outstanding Best Paper Award. That time IEEE Neural Network Society was not there, Neural Network Council. Afterward, it became a society as a part of computational in society. So this is a network multilayer perceptron you buy from market. It has a capability to accept numerical input and output 0, 1. But we say in real life problem, numerical could be non-numerical also, and output could be overlapping classes, how to deal with. So here comes the fuzzy logic, here comes the fuzzy logic. And during backpropagation, instead of 0, 1, you backpropagate through all output nodes to the input, depending on the memory scenario. So therefore, your oscillation of the boundary will be slowly. It's not abruptly changing. So it has capability is handling imprecise input, because it can handle numerical as usual non-numerical. It can handle linguistic input and adjust to the theory of, in addition to what can one uncertainty. So this was a benchmark model. Then it has many variants. One. So this is an example I am giving you the how to integrate this to concept. Then accordingly we defined in 1993 machine intelligence. That means a core concept of grouping all these advanced tools, whose list is not exhaustive, day by day it is improving, with the basic concept of patternization and learning. Now what are those tools? Fuzzy logic, neural net, probabilistic reasoning, approximate reasoning, case-based reasoning, all those hybrid tools, data-driven systems, nonlinear dynamics. And any intelligence systems are nothing but physical embodiments of machine intelligence. And in our institute, we established that unit, machine intelligence unit. But the work started at least 7 years, 5 to 7 years before. Note that was a Lutfi's Jades soft computing definition he mentioned in 1994. But the challenging issues we started much before that, because the paper was in 92. So although he formally defined 92, but different challenges were before 94 and before. But he has put everything under one consolidated umbrella and put 94. And Department of Science and Technology established its first national facility at Indian Statistics Institute, I think first in Asia also, that is the Soft Computing Research Center at ISI. Now in 2000, data mining became a buzzword because of WWW and Genome Project. But if you look at the statistical pattern recognition, that word was there, data mining. But that time we didn't have data. That's why it didn't flourish. So primarily because of this, and data is large and heterogeneous. What are the challenging issues there? For example, if you go to healthcare data, if you go to hospital, you tell your problems in terms of first of all, you write your name, parents' name, this address, etc. Then your pathological information. So some names are text, some text are numerical, some text are tick, tack, cross. So data is heterogeneous. And number of features is more than the number of samples, because you go to hospital only when you are sick. So you give your blood or something when you are sick. Number of people doesn't go. Therefore, the number of samples become small, number of features become large. But whether our decision-making problem when we started pattern recognition, basic assumption was number of samples is much larger than the number of features. When I started working pattern recognition, number of features were 2 or 3. That time we published paper in item transaction for feature selection. So that time our suppose was how to classify the sample space subject to those subset of features which gives maximum separability, and we publish paper. But today you cannot. Today all theories are bogus, because here data features are uncorrelated. So here what we have published in 2002, you cluster the sample space, not the cluster the feature space. So if you have thousands of features, if you can reduce it to few hundreds clusters, then take the centroid, it's a huge dimensionality reduction. So all you have developed before 80s pattern recognition literature, no way useful for this kind of data. That's why you get new terminology. We used to call it classification, now we call it a retrieval. We used to call feature selection, now we call it a dimensionality reduction. We used to have subset selection, we call it data condensation. So we are giving all new names so that it is much more understandable by the users. So it demands new algorithm because less samples one. And accordingly, two hot topics arose: bioinformatics, web engineering. You have seen so many IITs everywhere. Everybody is working bioinformatics. Students are coming for interdisciplinary, for internship, bioinformatics. Web engineering, bioinformatics. So what is data mining in a layman's sense from pattern recognition point of view? It has three. So statistical point of view, DBMS point of view, but I define always in pattern recognition form. That Pavitra Mitra, your faculty, we wrote that book and defined pattern recognition and machine learning principle when applied to very large and heterogeneous, large in both size and dimension. I call it data mining. And data mining has no meaning unless you interpret the knowledge and make it knowledge discovery. That it is a process of identifying valid, novel, and potentially useful and ultimately understandable pattern. Understanding means natural language. So you could say understanding means you understand in natural language. So here comes the natural language processing. So at every evolution you have emergence of new, here you have granular, because you have a large data set. So what is granular computing? It's a nature-inspired information processing paradigm with a basic element called granules. What is the granules? Say, look at, I'm in scenery. I've seen there some young guys, some old people there, some lady there. So without looking much, I can say these are my granules. When you look at a scene, you say water body, sky, vegetation, some habitation. So without looking at every point of the image or pixel, I can extract some information. So that means you are fine-grained universe, you are making it coarse-grained. That those are called granules in a layman's sense. That could be physical granules, it could be granular information also, in the form of rule, in the form of equation also. Then I call it information granules. So having granules, which are collection of indistinguishable objects that are drawn in terms of some property like similarity, functionality, physical. For example, in a gene data, RNA data, their similarity comes in terms of functionality. In a vector space, similarity comes in terms of distance, proximity. So granular computing means you extract the granule, abstract information from the data, and then computation is performed using those granules, not the data. You forget the data. That means you playing with a compressed information, and since you are playing with the compressed information, your mind says it can lead to computational gain. Therefore, you can use it for data mining. Now, when you are making compression, your information lose. You are losing information. Nothing is free, but your computation is very fast. And most of the data mining problem, we do not need accuracy. If you need accuracy, you start from there. Then you little pay instead of starting from the scratch. Understand? So that's why granular computing is still in the research phase. We are doing for a little more than a decade. So, for example, you say granule could be age. Granule age means young, not so young, old. When you are driving a car, granule could be left, slightly right, not so left. So these are called granule. In a school, every section can be considered as a granule because section is determined by age or marks obtained in the previous class or sex. Everything. In an image, every similar color intensity can be granule. Even the same one pixel can be also considered granule. That means if you increase the granularity, then you are actually approaching towards fineness. If you are making coarse, that you increase more granule. So you are losing information. So then, so note now, see the granulation concept was already in fuzzy set theory, because membership function means it is granulating the feature space. And in rough set theory, though it is doesn't mention about the granular computing, but the concept granule was a rough set, because rough set was defined. Rough set means is a crisp set defined over a granulated domain. I will now explain this one. What is rough set in one slide? This is a granulated domain. Say in a school, every section is a granule. That means here all the students in these sections are uniform with respect to some features x and y. If you increase another feature, then granular size will be reduced. Now within of this, with this, over this granulated domain, you define a crisp set, crisp concept. And then you try to approximate this set or concept or this region from inner side and outer side, but in terms of granule. So from inside, inner side, if I do, I get this yellow one. That means which definitely belong, all these granules which definitely belong to this set. From outside, it's a brown set. So you approximate the crisp set in terms of granule from lower side or upper side or inner side or outer side. So this is what is called lower approximation. This is called upper. And upper means that includes lower. Lower means definitely belonging, positively belonging, that I have no ambiguity. Upper means definitely as well as possibly. Possibly means upper minus lower is called possible. They create problem, uncertainty. So if you reduce this granular size, then you reduce this uncertainty. So accordingly, roughness is defined as 1 minus cardinality of lower, cardinality of upper. If cardinality of lower equal to cardinality of upper, 1 minus 1, 0. And when would be lower and upper cardinality equal? Because if there is no granular. So if granularity is there, you are leading to roughness. In an image, there is no granularity, but in a picture. But when you make it discretized, x-axis, y-axis 0 to 31, and intensity value say 0 to 31, that means you are introducing granularity. Because you are discouraging means losing information, you are increasing granularity. There uncertainty. If there is no granularity, 1. So the rough set is nothing, though the name is rough, but basically crisp set with rough descriptions in terms of lower and upper approximation. And this vague definition of the set in the universe in terms of lower and upper, that signifies the incompleteness of knowledge. Because why incompleteness of knowledge? Because of the granularity. And granularity is formed because of the relation. Therefore, you can minimize incompleteness to make a decision. I am not going into this. So it had two applications. Uncertainty handling and granular computing. When I was working at NASA, I picked up this subject because from the East European scientists who did not have job, so they used to come to USA for internship. I do not know how many of you know, NASA not only funds research for space also, but they also fund for research for university students, for internship, fellowship, for PhD also. So I picked up their subject. That time I had little idea about image processing and pattern recognition back in 90. But I can see that uncertainty which I dealt with image processing, pattern recognition. You can use lower and upper, and granular computing term was not there, but the granule concept was there. So we can pick up the one. So accordingly, we can see that there are so many applications of granular computing, video tracking, microarray selection for cancer classification, and also for say drug-resistant microRNA, link prediction or community detection in online social network, neural network learning parameter, air quality interpretation, recently environment data. So these are all areas we have worked, using granular, and these are all called big data. It's a 4 big characteristics that came in 2010. Big data. Large volume, large velocity, large variety, large veracity. Veracity means conforming to fact. And Indian data are fake data. Internationally it is called Indian data means fake data. We always manipulate data. Our voting election data is a fake data. Our education data is a fake data. We do not give the true thing. Similarly, our because of the plagiarism, our output ranking is also fake. It is internationally known. Chinese and Indians are very good in plagiarism and corruption. So our Indian data, that is called veracity problem. And each V leads to a new research topic. Each V leads to a new topic. Now, I call it one example I show in the third part of my talk, unsupervised video tracking. That you have no idea about the one. It's called prediction based, where you use granule. What is it? Given an image. In a video means sequence of image frames. If you do not work in image, it will be difficult to work in video. You should work first in image, then you work the video. Video means you have additional feature means temporal information. If you subtract 2 video frames, then you gives the moving object, because static portion they get nullified. So given a frame image, how do you compute the spatial color granule? You start from a one. It's called our region grading method in clustering. You start where you compute the color similarity, put a threshold, add. So you get natural clustering. And we do it in temporal space, different space. Then out of, so if you have 3 frames and 1 current frame video, then we can have roughly estimate the location of this object in terms of color and their coordinate all in 3 previous frames in terms of lower and upper approximation, and use this information to compute the nature of variation of the object, that means speed, direction, acceleration, and approximately locate the object in terms of lower and upper in the t+1th frame. We are prediction, and then we compute the roughness, and if roughness is small, low, we compute, we say it's a track. If roughness is more, that means object is occluded, then we compute intuitionistic entropy, which indicates the amount of occlusion. And then I put this upper minus lower pixels in the this side and that side. And wherever it goes minimum roughness, we put it. So it handles partial or total occlusion. Just one example like is unsupervised tracking. So what do you do? You have an image T, T-1, T-2, T-3, and take union. So you get one image. Then T-1, T-2, T-2, T-3, you get 3 frames. So then you take convolution. You say electrical engineer, you get 1 to 3 point convolution. That is 1 to p point convolution, and you get two p point matrix. One is the lower and upper. And this convolution operator is, if you take intersection operator, you get the lower approximation. Intersection means minimum, they will be all present, that means they are sure. And if you take union, and out of those union, you take those granules which have non-empty intersection with the lower, you get upper. So for every 3 frames, you get 3 such lower and upper approximate value for the T+1 frame. So this is an example. You take convolution, lower approximation, upper approximation, and from that you compute direction, speed, and you approximate. So this is a London Metro. Could you please click it, the video? Oh, a playing. Yeah. Here we have frames per second 15 and p equal to 16. 6, that means 5 previous frames and 1 current frame. This is just prediction actually. This is just a prediction. It's not classification or estimation, just prediction. That's why we are getting it one. Now you see that these are all basically machine learning algorithms. I call it shallow learning in order to discriminate this one. Now, its performance of machine learning depends on the number of previous samples. So, larger the number of samples, larger would be the performance. Today we have abundant data, therefore, deep learning has become a meaningful choice. But deep learning performance, it needs large previous data. Therefore, it is difficult to engineer and also time consuming. So, when it is considered difficult time engineer, we have another technology called granular computing. So, why don't you bring it there? So, that gives rise of, my goodness. So, I am explaining what is deep learning first. What is deep learning in a layman's sense? Learning in depth in different stages. Obviously, it is a subset of machine learning. It is characterized by learning the data representation rather than the task specific algorithm. In machine learning, usually we learn the task. Given this, given that, given this, given that, we learn the task. But here we learn the data representation. That's the beauty. And abundant data makes a meaning choice. DL process is time consuming and difficult to engineer. Therefore, the new concept of granulated deep learning. Because granulation we have proved to be cost effective at the cost of little efficiency. So, reduce computation time, improve performance. Here we explain the concept of granular deep learning, which we described in 2018 based on one of our MTech dissertation from Calcutta University. So, this is a typical CNN. CNN is good for image and video. All architecture are not good for. LSTM model is good for spatio-temporal data. So, here CNN is a convolution, then followed by max pool, ReLU, subordinator. Now, here instead of in usual convolution, you put a 3 by 3 matrix, you take multiply dot product is called. It's called, you scan it, you extract features, convolution networks, convolve. But we say in an image, I may not need the background also. So, if I granule it with a number of, say, you have 32 per 30 image, if I reduce it to 9 granules. So, instead of scanning 32 by 32, the 3 by 3 matrix, I can scan only 9 times. I put 9 times, I repeat. So, there will be a drastic change in computation time at the cost of little compromising efficiency. That was our concept. Then we have increased it to our Onima's PhD thesis, one of the chapters, that it is a multi-objective detection, 2 stages. 2 stages means you localize, then you track. Obviously, it is a faster, more accurate rather than single. 2 stages means, so what is the beauty here? This is the available RCNN, region-based CNN, available market, trained network. But here I put this extra by red. And I take the entire video as input. There they take input, because why I am taking, I will consider the temporal information in the granulation. So, my objective is to put spatio-color and spatio-temporal information. What is available faster RCNN, which is widely accepted, they didn't have it. Very simple concept. So, I take the input or field, I compute the granule, spatio-color granule, then we this is temporal granule, this is spatio-color, then I take intersection again, I get the spatio-color, spatio-temporal. That means I am reducing the background as much as possible. But in the process, I may lose some information also. So, here again I took one. Then afterwards, I put out of the selected those different anchors, because if I have missed some original information of the object, put anchors, and that is my input to somewhat better see. So, therefore, in the process, what I get, what are the advantages? That you take the video as input, you take spatio-color and just temporal information, that you are getting more information using. Then you are not using the all pixels, but only a selected pixels. That means region of interest by selected only. The similarly corresponding FT domain, I am taking selected points. Therefore, I will gain in terms of computation time and accuracy. And accuracy. Why accuracy? Because I have selected the correct ones and then I have taken the possible losses, etc., instead of taking the entire one. Now, if you use it for, say, in a steel plant, I will not mention this, it's a security issue, it's a steel plant data, there are 8 objects. Now, in a traffic signal, why deep learning, why not conventional machine learning? Because most of the images you get is a very small, because it's a camera is at the, from the distance, and image could be noisy, cluttered, shadow, occluded. So, detection of these individual objects using conventional machine learning, it's not so easy. So, if your detection is not good, tracking will not be also good. But on the other hand, I have got huge data for the last 1 year or 6 months of this scenario. That is my asset. So, I will go by the deep learning. Otherwise, if you are objective on human base, I can extract human face. I do not need this deep learning. It's a little expensive also. You extract feature, you object, and your moving object, you track it. But here I cannot do this. So, detection performance, here I have got 8 objects, truck, loco, so scooter, bike, etc., human being. So, I will show the results on one. Yeah, can you please video? Yeah, just it's a spatial color. I have skipped one video. See, spatial color information and the red signals, red circles, they are showing that which you could not detect by faster RCNN. But there, faster RCNN has 6 frames per second, but you are reduced to 5.55 cents because you are taking spatial color information. Now, next one. We are taking spatial temporal, that is very interesting. There you have further increased to 5.6 compared to 5.5. Again, the red circle means which you could not detect by spatial color. So, spatial temporal helps you identify that. And here, in spite of using additional intersection operator, still it is faster, because you are reducing the number to very small but effective object regions. That is the beauty. So, this is the evolution, my last slide. So, as I mentioned to you, again summary, pattern recognition started in 1960s, image processing 1970s, AI ML 1980s, 90s. See, around about 10 years back, we are having all buzzwords. Today we have got data driven side. Now, my request is that during each evolution, you have different tasks to cater to the need of the variability of data and the varying decision making tasks. So, you have to go it. But for beginners, I request that new terms and technology, big hopes, but don't jump into the subject without knowing the background. For example, if you want to work in node deep learning, then you have to know shallow learning. If you want to know shallow learning, then you have to know artificial intelligence, machine learning, that means neural networks. And if you want to know neural networks, you have to know pattern recognition, that basic concept of classification, clustering, feature description. Unless you do not know, I am seeing nowadays in the newspaper, they are giving the mathematics behind Siemens algorithm. I am joking. That was the elementary thing we have been teaching our students and the one. Why it is going in newspaper? Because nobody is using. They are using just some software package. So, New terms coined, technology one, caution. Don't jump into the subject without knowing the functionality behind it. Otherwise, what has happened in 1980s, when neural network revived, big expectation. India government pending, lots of journal came out, but after 7 to 10 years, subject died. Because we didn't bring out any new architecture. Everybody is using multi-layer perceptor and trying to solve all problems. In bank, they are trying to estimate the dollar value. In race course, they are willing to work. So they think that everything can be solved. No. That's why many journals wound up. IT transition neural networks, they change the name to neural networks and learning system, and they are publishing paper on support vector basic, because no one is working in neural networks. Neural computing, neural networks, all famous journals which evolved that time, they are not getting publishing paper in neural network. Now again, because of deep learning, they are again wake up. One. So with this one I conclude, and before that I mentioned any excessive talk on any topic by ignoring the growth of other disciplines may same time be no good, because it affects the overall progress of science that benefits the nature, our society and mankind. Please keep that in mind. And I do not want to see, because machine learning is learning from previous examples, so I do not see that for deep learning that same situation will recur. Thank you. I acknowledge my students and younger colleagues who has worked with me for. I didn't work with any big professors in my life, so I always, my students are my asset. And thank you very much. Thank you. Thank you. How much time I took? 45 minutes? 45? I skipped some slide, basic slides. So if you have any question, one or two, I can. Yeah.
Is neural network a lazy way of doing computing? Because what companies are doing is that they are putting in advanced GPUs and advanced NVIDIA advanced machines, and companies are simply throwing resources without developing new frameworks or new models. Means it's all back propagation and optimization of parameters. But the essential architecture is still remaining the same. So are the companies opting an easy way out in neural network?
That's what I'm telling. That's what in 80s we had. We had that few multi-layer perceptor. It's a very everybody used. We had some handwritten character specific, some of the one. But we failed to develop new architecture. We failed to provide the science behind functioning of the neural network. That's what survived one. Today situation is even worse. After 2 decades, 3 decades, young kids, they know only those software patches. They do not ask us how to solve the back propagation. They do not write the back propagation algorithm. If you write the back propagation algorithm, at least that time, my students, Susmita, Mitra, Nikhil Pal, who are now international scholar, that time they wrote the back propagation algorithm. That time competition was not that easy. So they wrote A1. So they know what is back propagation. So they know how to manipulate, how to make advantage. But now these kids, they do not know back propagation. See, that's what I'm saying, alarming. Now what you are getting, basically it's a T20 match, fast food. You get the fast food, you are getting result, you are getting promotion, and you are publishing a lot. Too many journals, too many publishing. And being still in some academic editorial board, I can see that. But still they are getting a promotion, they are getting their PhD, because PhD now you made a quantification to ISBN journal or something. As soon as you make a quantification of an excellence, it is very likely that parameters who are responsible for quantification, that will be manipulated. And ultimately the whole purpose is defeated. That's what in ranking 1. 2 days back I saw in the newspaper, in India, how many plagiarism came, even from 2 IITs, Jadavpur University, basically. Because they said, sir, we need ranking. So when you want to make a ranking, that is number. You are at 3.5, I am 3.8, so I am superior to you. Right? This is the one. well, I can only criticize. I do not like this system. When we started working for PhD of our students, we said every chapter has to have a one good journal publication. Without IEEE 2 at least, I do not publish. Even the ONIMA, that well, 2 IEEE transactions, full paper accepted, and third one under revision. So okay, you submit thesis. Because why I am going to IEEE? At least there are some good reviewers. It takes time to publish in a very good journal, but it is worth doing. And once you develop that habit, you won't be able to get it off. But once you develop the habit of publishing anywhere, just by say increasing number, just to get a PhD or giving a PhD, because why giving it? Your promotion is associated with this. It was difficult to get rid of journal. At our time, there was no PhD requirement. When I got full professorship, my thesis, students' thesis were submitted, Nikhil Pal and Ovita era, not awarded. But we had quality paper. So that is a big concern to me, at least. The way I'm seeing, killing some subjects. 20 years back, we killed physics, chemistry, mathematics, because in the name of IT. Now nobody goes. At our time, best students used to go for physics honors, Presidency College. Even in any college, physics honors. Now you are killing civil engineer, electrical engineer, engineering, mechanical engineering, where is the core engineering. I do not see it good point. As you mentioned, it's a valid point. You please, who are in industry, you talk to them. In the newspaper now coming the science for Kane means algorithm. What kind of thing? Yeah? You are good at library and see, read. Basic paper, our papers. We are explaining K means algorithm. We are explaining fuzzy K means algorithm, how fuzziness is coming, how it is improving. Very, very unfortunate. Yeah, please, someone. Yeah. No. This is one of the criticisms we have been facing since still 75 for pattern and image processing. No one algorithm is good for all kinds of data. That has been always, but we can give some guideline. In biophysics data, that's why I'm telling, when you have the question of overlapping, if you have sufficient data and the data follows some distribution, go by Bayes classifier, because that is very risk. But today we don't have sufficient data. Data is scanty. So Bayes classifier should not be used. So that's why it's coming non-parametric algorithms. Fuzzy set theoretic, rough set theoretic, neural networks. Understand? It is a demand of the data. That's why it is called data-driven science. Because that's why I say before 80s what you published, today you cannot use for this data. For bioinformatics, we give very good results using just simple rough fuzzy minimization. That means basically you are playing with uncertainty. Whatever way you feel like. I give 2 approaches. You can use probabilistic approach also, but for that you need data. But there you can mix also probability in terms of lower approximation, because all theories go to the same place, minimizing uncertainty. Anywhere, threshold. No. See, thresholding will be always there. Thresholding, that's why it's a concept of soft thresholding. So don't make hard thresholding. That's why fuzziness became so popular. But before that, when we worked at image processing, we put the threshold. This is the one, this is the object, this is background. But then we say, no, you are committing error. So keep that information, because information is expensive. Gain information is very expensive. So keep that information as long as you keep it. Once you put it threshold, similarly here, where they say spatial color granulation, we put threshold. Otherwise, how can you put the granule, and then how can you reduce the completion time? No. Many such. That's why I said these are all just problem dependent. These are problem dependent. There are some guidelines that what kind of uncertainty is there. That's why I said my last that you look at the data first. Don't look at the algorithms. You look at the data, what data demands. Then you read those algorithms which will be better. It's not like blind way. You try this, try this. No. You look at the data, you read the data first. See, we don't have time to read the data. We put some algorithm, we have some machine, we put it, get the result. Even if it gives bad result, we do not have mind to interpret also.
Our next is ready. You can discuss offline. Thank you so much. Thank you, Professor Pal.
Thank you very much.
So,
Thank you.
So, as the token of gratitude, we would like to call Professor Maiti to present Professor Pal with
This kind of techniques are being used to locate the items, and also several other like RFID kind of operations are being used. And agri-food supply chain is a very interesting area where a lot of improvements has been taken place in collecting the produce from the farmers, distributing it through the nodal agencies in the state sector.
Hello?
And then port
Hello?
management
Hello, sir, can you hear me?
is another very,
Hello?
recent fields where a lot of operations of the
Hello? Are you able to hear me, sir?
PM
Sir, you have little problem with your network.
Yes.
Sir, you have little problem with your network.
You have?
Our side it is okay. From your side, I think there is little problem with your network.
But ma'am, here I am listening to you and I am also communicating you. I don't understand.
Oh, actually, there was some breaks in between. Now, I think now it is all right. Like, kindly
But
continue, sir.
Same was there in the beginning itself. Anyway, you please remind me if there is anything miss, huh? Okay?
Yes, sir.
So, again slide is on the screen. Hello?
Yes, sir. Yes, sir.
Okay. So, I can say then we have manufacturing functionalities where the R&D, production planning, control, management type of topics like maintenance and diagnostics is to take place. Warehousing is another very interesting component where storage, assignment, ASR, techniques, they are We have logistics systems, logistics projects, how do many lead time reduction from the starting from procurement to delivery. And then there are many particularly advanced technologies when it is coming up, when we have IML applications, when we have many OR modeling, and also several type of structures like control towers, digital twins. Then it found that
Professor Theory, can you please mute
manpower.
your video? Stop your video because your voice is
And
dropping.
then data
Professor Theory, hello.
management is our. Hello?
Yes, sir.
Actually, your voice is dropping, so can you please stop your video? Camera particularly.
No, I stopped the video.
Okay, thank you. Please go ahead.
Okay. Now it is all right? Hello? Hello? Hello?
Yes, sir. You are visible. Your PPT is visible.
And I am also audible, no?
Hi. You are hide. Your PPT is visible. Your audio is good. Please continue.
Good. Okay. Then we have demand volatility is another, problems which need to be resolved and predicted to some extent. And there are quality control issues in packaging defect. That is why many of the items are returned. And then limited transport capacity, because most of the trucks that we use on the ground, they are not of very high capacity. They need to be joined together, and many of the operations like plantooning, that is 3-4 trucks need to be joined together, so that you can save some of the money while sending a large amount of goods in one go. And then another challenging problem is exchange rate and foreign transaction cost. And of course, the current problem is basically sustainability, that how to save the energy and save the environment, and then minimize the carbon footprint, and then go ahead with the logistics operations. So if you see the overall challenges, if I can envision, and then they are with respect to a lot of digital technologies are used, and that is also giving scope to many other areas, like when data-driven modelings are used, then data can be fudged, and data can be hidden, data can be snatched. So in that case, cyber security is one of the major issues. Then, as I told you, that international wise also, because of many advanced technologies are coming up, so there is a less number of trained persons, so we have to improve that. And because of the global competition coming up in every country, so we have to have more GDP coming from the top 3 economies, and therefore the quality requirement, delivery, price and trade wars need to be properly adjusted. And in this context, many of the foreign policy of our government, they are producing very good results, and that is why you see our economy is booming. And I think we are going very soon going to be the 3rd largest economy in the world. So as you can see that the automation level is increasing, and that is why the efficiency of the logistics operation is also improving, and the cost of the operations is also coming down. And many of the new technologies which are being used, like blockchain, like AI, ML, and also many of the QR code kind of things, they have also simplified the logistics operations. And environmental issues, particularly recycling, remanufacturing, and many of the energy savings, they are being in the forefront. And of course, because of custom-centric supply chain, you can see many of the products, they are being sold into e-commerce way, and multi-channel, there are other particularly omni-channel kind of ways. So people are utilizing these channels to have the more personalized and customized products. And many of the disruptive technologies which has come up in the recent years, and they are affecting and they are improving logistics operations, like mobile internet, and many of the like knowledge graph and knowledge network kind of things with the help of ontology. And cloud technology is playing a big role, because most of the operations that we are doing particularly when we are handling big data. So they are coming in a big support for us. And I particularly AWS, Amazon Web Services, is now being massively used for handling many of the things of machine learning and AI operations, where you need not have to have very large memory and large processing speed of your computer. Then blockchain is other way where the ledgers are being used, and therefore it's very difficult to copy and manipulate the data. And they show the safe and secure transactions actually. And many of the vehicles which are used for small places handling like port and warehouses, where it is being proposed to have autonomous vehicles, so that the cost of labor, driver, etc. can be reduced. And many of the devices for energy storage, like battery, like other solar and then hydrogen fuels, they are being now talked, and somehow experimentation are also going on in this direction. And several fiber-oriented materials are coming up to reduce the weight of trucks and other carriers. And big data, all we know that how they are affecting, and other technologies are well known. Then these are the advancements like technology-driven digital transformation, AI-driven automation, cyber security and risk management, remote work and virtual collaborations, and generative AI and explainable AI. So we are in the era of using all these things to disrupt the operations of supply chain. So if you see the different analytics which we talk in the supply chain, their functionalities are like say descriptive. If you talk, they are dealing with the how the little data available can be used for taking decision and particularly resolving the uncertainties. And if you go to diagnostic, then how we are having the like hypothesis testing and then correlation analysis, regression analysis, and they can be used to identify the different technological issues. And the moment you come to predictive, then which is very massively used in the logistics and operations like demand planning, stock planning, storage planning, and customer choice, test, guessing, and also that what are the different other items can be put into the demand list of the candidates in advance by looking into account the ChatGPT and others. So you can say that this is one of the large scale use of the predictive ones in the supply chain. And then the prescriptive one is basically combination of both, where we are using some sort of prediction and then optimization, like price optimization, risk optimization, markdown optimizations. They are being used by this one. And now we are talking about very interesting area where we are using both the combination of predictive technology like AI and ML and then optimization. So you can say many of the rules of the business need to be defined, several machine learning algorithms are being used, and then many of the OR techniques are being linked in order to minimize the decision error. And that is the one of the area where most of the scholars are focusing currently, that how they can mix both. So I have some here discussions on this, like how both the prediction and optimization are working in logistics domain. So as you can see, here the straightforward because of the utilization of prediction and results, and that enable us to derive the optimization issues, and that lead to target indices. Like say, if one side variables are there, their value we have to predict, and that error need to be minimized, and then they need to be fed to optimize the overall functions. Whereas in conventional optimization, as you can see, there difficulty due to insufficient information, and there were problems without consideration of the predictive error. There is a danger of slight discrepancies will result in the more losses. So if you combine all these things, then you can say that this kind of problems which are coming up, and this framework, like historical asset and stock data that we are getting from the supply chain, and then we have technical indicators and some of the lagged observations from the data, and then we are using the famous algorithms which are well known technology now, LSTM, XGBoost. From there we use to predict the stock, and then we go for the alpha model or risk model, and from there actually we get the value of error about the demand and variables that we want, and then we fed it to the optimization module, because this is the prediction module and this is the optimization module. And there we do all the analysis of operations of maximization, minimization, mean variance analysis. And you can see many of the portfolios are constructed where we have many options to choose, and then those options have to be preferred, and they link with the optimal portfolio kind of operations. So same way, if you want to increase it, then many of the demand factor sensitivity analysis for demand prediction, and they are being used with the NNR other models, and different kind of data that we fed is the demand distribution, logistics, service quality, purchase power, and they are coming from the different stats operations like historical sales, demographic statistics, many of logistical and log files, and finally, if you see the facility location optimization, which is one of the things that can also be taken care with help of these data, and also how they are being used for carrying out the operations. And it is one of the interesting application of the drone and truck combination that needs both the operations. That is how we can have pursued with the prediction and optimization. And this kind of problem we just address by having some data from the Hong Kong firms, and where two of my students have gone, and this was reported in the IEEE Intelligent Transportation, where actually we have the synchronization operation between the drone and truck, and they were particularly distributing the goods during the lockdown period. And as you can see that these are the different buildings where they have to deliver the things, and they are the storage from where the truck is coming up. And here interesting part is that how to schedule the speed of the vehicle as well as the nearby storage, so that different locations that they can be served properly by the drones, and they are refueling their materials which are loaded on the truck. So this is the 3 case studies that we have prepared for one particular districts of Sitap, and the data we have taken from the Vizag, because they have the big portal and they have opened it for 2 months for us, though we have done 7 particular case studies. But just a glimpse, I tell you what we have done here. Idea was that many of the rivers which are there, sometimes because of flood seasons, there is a difficulty for the local peoples actually, that how to place them, particularly in and around the bank of the rivers people who are there. Then we have taken the data of the districts, and then we found that what are the different places which are flood affected, and number of schools which are there. Yes?
Your PPT is a stop shared. Please start again to shared.
Okay.
Yes, sir, is visible.
All right?
Yes, sir.
So here also we have objective was basically to have the demand planning for many of relief and large scale evacuation during the flood operations, and then identification of the cluster, and then giving the relief material to them, and which are the locations where we can keep it. Very simple map based analysis has been done, and accordingly we have given them a very good portal through which now even district officers can also see this kind of operations. They can use it. So idea was that how the data which are available by the Vizag can be used to solve the local problems using Vizag technologies, particularly mapping and information about the distances and villages. So that was one of the things actually. This was about case study. And then there is a midday meal being distributed, and keeping in mind the principal operations that has been built up by Achai Patra Foundation. Then we have also thought that how many, around 202,000 number of schools which are being served by the trips. So this is where we have minimized the cost of midday meal distribution to the schools. This was another problem we did. And then about agricultural products which are when the crop is ready, And then many of the schools are being used as a collection center using this technology, and particularly many of the distance-based matrices which were provided by this data, and they are very simple to use. And of course, somewhere we have used the k-means clustering also to find out the solutions for this. And many of the other industrial applications which are possible because of digitalization, and they have found enough improvements into the area like airlines operations, their crew scheduling, and many of the ground people scheduling problems. And we did for Air Asia, particularly these operations. And then shipping and port logistics is one of the major area for the improvement by using digitalization. And supply chain resiliency has been proved to be a very essential element, particularly when there is some disruptions coming up. So nowadays we are not talking about lean supply chain, we are talking about the resilient supply chain, so that you can have the what you call items can be delivered in time, and also you should not be stock out also. So demand planning and sales forecasting became quite simple because of the many advanced learning, deep learning algorithms and other machine learning practices. And then fashion product sales predictions, inventory and warehousing, air cargo handling, all these areas, they are massively using the digitization. Application of many of the machine learning tools that we did for one particular company in Bombay itself, that how we have noted the consumption pattern of around 104 steel types actually. Algorithms we found, and which one gives better results, that we have chosen and given it to them actually. And this is a very interesting problem that we did for one of the famous FMCG company, where we did the video analytics to know that how much actually the money can be saved and amount of powder can be saved by creating better foam. And this foam is the quality that determines the, how much good quality washing it is being done actually. So these are some of the interesting applications that we did, and these are some of the other problems, like we did demand prediction for a cement company recently, where they have a large number of operations in India, and it was very tough problem because data they have not collected in proper manner. So a lot of missing data were there, and that we faced a lot of problems in solving that first. That is cleaning up the data, then adjustments, and then seasonal adjustments and different type of models, how they are being used actually to find out the demand, and accordingly we have solved these problems and also reduced their consumption. So these were the different levels, like district level planning, regional level planning, dealer level demand planning. So 3 particular levels we have addressed this problem and given the solutions to them actually. So now coming to this is the result, that in each zone, like east zone, northeast zone, south zone, and all those, so we have predicted the demand, and accordingly amount of error that was noted, that also fell. But this has given them considerable benefits, what they were reporting to me. Then the final framework of the whole analytics and the digitization, this is the end of the slide. As you can see, that these are the different kind of data from the different sources and entities of the supply chain. Through these devices, this data is captured like barcode, panel, RFID, and then this is fed to the information sharing modules like communication network, IoT gateway, small bases, and then whatever information we are getting from this, and then they are to be in form of data, and then it is cleaning, integration, and then different kind of files are being made, and storage through the cloud, and all those things can be ensured. And then all the 4 kind of analytics that we use to solve the different problems of logistics. So with this note, I just want to end my presentation, and yes.
Hello. Hello,
Yes,
sir.
ma'am.
Can you hear me, sir?
Yeah, I can hear you, ma'am.
Sir, thank you so much for sparing your time. And we would have been happy if you would have been physically here.
That's
But-
but
we are
there are limitations from my side because we have to actually open a center in Odisha,
Okay.
Mumbai.
Okay,
So
okay.
that uncertainty is killing a lot of time from our side.
Oh, okay, okay, sir. Okay, sir, thank you so much.
Thank you, ma'am. Thank you very much. It's
So we are now having our going to have our third lecture, and next our keynote speaker is Dr. M. Ram Manohar Babu. He is now a professor of practice in IIIT DM Kanchipuram since 2023. He has superannuated from DRDO on 30th June 2023. He completed MS in Mechanical Engineering from JNTUH. He has been awarded PhD by College of Engineering, Andhra University in the field of acoustic emission testing of carbon epoxy filament wound pressure vessel. He joined DRDL in year 1986 in program Agni, and has been responsible for developing fabrication airframe structures and structures, testing and evaluation and integration in the capacity of system manager and deputy project director. Hello sir, I welcome you. So sir's PPT is ready. Can you please share the PPT? No, not this one. This one is the next PPT.
Yeah.
Yes.
Come to the first slide.
Can you please make it full screen?
Full screen. Good afternoon to all of you. It's a privilege to be here to present my experience with respect to long range systems development in DRDO. In fact, the development of missiles started in DRDO in 1983 as part of integrated guided missile programs under the leadership of late Dr. Kalam, and long range systems was one of them. And today we have matured, and the country is self-sufficient in the technology, and we have developed various variants and which have been deployed in the hands of armed forces. And I thought I'll share my experience with respect to the usage of the approach of system engineering, what we put in the design and development of the long range missile systems, especially the high requirement of quality and reliability perspective. And if you look at any missile system, the long range missile system, it has many subsystems. So varied subsystems, if you look at it, right from airframes, propulsion system, control systems, guidance, navigation, onboard computer, power supply system it need to have, and it need to have a lot of intelligent units on board, and we need to have a lot of onboard softwares to operate it. So many varieties of systems, and all the
faculties of engineering, many faculties of the engineering and many faculties of science, they have the role, various role in developing the various subsystems. And that way it is highly multidisciplinary system. I think that we should understand. And if you operate one project, it is, we call it as in project management mode. If you operate many projects, we do in program management mode. Number of projects also we operate. And if you look at it, all these multidisciplinary areas, whatever I said, they have been contributed or they are being contributed by many stakeholders. Whatever the stakeholders I am showing here, they are all involved in the design development of missile systems. So DRDO itself, we have lot of multifunctional labs which involve with respect to their functionality, and a lot of academic institutes, R&D institutes of government, public sectors, and many private industries, where large varieties of private industries, all of them they involve. So that way, if you look at it, the managing the program, managing the project, it's a highly system oriented, and system engineering approach will give the right product, right system, which will be optimum with respect to its performance and highly reliable, and it should come out with the minimum possible cost and in minimum possible time and with the least risk. The risk can be with respect to the technologies or materials or components or functions. So that way the system engineering concept plays a very, very important role in overall design development of the missile systems. So then I thought, before entering into the way in which we handle the design development of the missile systems with system engineering, I thought, what is the classical system engineering approach? I want to throw some light, and I have taken the guidelines from NASA, which is for the aerospace systems, which is highly relevant for us. And if you look at the NASA system engineering approach, basically, a system engineering approach is a methodical, multidisciplinary approach for the design, realization, development, and technical management, operation, and finally, for the entire life cycle, you have to manage up to the retirement of the system. So we have to see right from the top the expectations of the users, the expectations of the stakeholders. They have to be mapped to the entire life cycle of the system. That is what we call it as system engineering approach. As you know, system, when I define the missile system, as I already said, it has got a lot of various subsystems. So various subsystems and processes and equipment, test methodologies, and even persons, the skills involved, technologies involved, all of them, they get integrated into the development of the system. And if you look at the system engineering approach, there are 17 standard processes which are there in system engineering. The system design processes and product realization processes, they together they form something like 9 processes, and they are the project execution processes. And whereas technical management processes, they are for monitoring, controlling, decision making, and assessing the project at various stages. And the system design processes, they define baseline stakeholders, expectations, and they map the stakeholder expectations into the design requirements. And the design requirements from the stakeholders, they have to flow down from the highest level from the system to the subsystem, to the component, and finally to a standard part or a PCB board or whatever it is, the least level component. The specification should flow down from the highest level. So the user's expectation should be mapped across the system, right from top to bottom. And if you look at the product realization processes, they are the processes where we implement the design. And as far as the design implementation is concerned, we have to implement from the lowest level. That is, a component has to be fabricated first, and it will enter into a small subassembly, and small subassemblies have to be tested and evaluated, and they will enter into a major subassembly, and then major subassemblies get integrated to make the overall system. That means the flow happens from bottom to the top as far as the implementation is concerned, and both the activities shall be monitored by technical processes, monitoring processes, in the form of making the project plans. You'll have to have the reviews, design reviews, and configuration control, data management in the form of documentation, etc. And sometimes decision making also you'll have to take to approve the designs and to approve the component and test and evaluate the component subsystems, etc. This is how the integrated approach of system engineering will happen in the project management. And if you look at the project management activity on the right hand side, PPC, project planning and control, they are mainly concerned for the resource management, scheduling, cost estimation, risk management, etc. And the system engineering approach and project management, they should work together, they should integrate, work together. And there are certain common features. If you look at them, the common processes which have been shown in the overlapping area, like the stakeholders, risk, configuration management, data management, reviews and schedules, all these are all common areas with respect to system engineering as well as the project management. System engineering will give the technical requirements for all these common areas, whereas the project management, they give the scheduling inputs and cost inputs for all the activities. So as a whole, the entire program management or project management, they should work with hand in hand with system engineering and with an overall approach, that is from the top to the bottom with respect to the specifications, and from bottom to the top for realization. That should be the approach. And if you really integrate the entire system engineering approach to the project, how it looks like, this is the tabulation has been shown. If you look at the phase of the project will have a pre-phase A, that is concept stage, and then it goes into the concept and technology development, and then preliminary design, and then final design and fabrication. Then it enters into the integration, testing and development. Then you'll have to have the realization of the operational unit, and operational unit has to be deployed in the useful scenario, and finally it has to live its life before getting its retired. And at every stage, the system engineering plays a vital role. Let us say at the conceptual stage, it looks into the expectations of the stakeholders, that is the users, and then convert them into the basic design requirements of the system, and whether a system is feasible to be developed meeting the customer expectation. That feasible study will be done in pre-phase stage, and the feasible study will be based on lot of analytics and then maybe modeling and simulation studies, etc. And then in phase A, concept and technology development, all the the feasibility study, whatever has been done, that will be converted into the basic design requirements of the system, and a design report will come out, system conceptual definition will come out, and the conceptual definitions wise, if you look at it, the entire system has to be defined right from the top to the sub-assemblies and the components to the bottom level. Then we will enter into the preliminary design. In preliminary design, the entire design has to be conducted right from the main system to the subsystem and to the components. Once a main system design has been done, the main system will give the design requirements as an output to the next layer, lower level, that is subsystem, and from the subsystem the requirements will come and get generated to the lower level, that is to the component level, and from the component to the material level or standard parts, etc. And then the final design and fabrication is the next stage, phase C, and wherein the complete detailed design will be carried out and certain prototypes will be made and critical design reviews will be conducted. And then this is the stage where we undertake the realization of the product, and product realization is concerned, as I said, they follow from the bottom to the top, and components will be made and integrated subsystem level and system level. That is how the final design and fabrication will be made. The end product detailed designs will be the output at this particular stage. And phase D, system assembly. The system assembly and integration is the stage. This completely we call it as the development phase. Whatever the components and subsystems which have been made and developed, they have to get integrated and they have to be tested, evaluated, and after doing the evaluation, then we need to have the field test, what we call it as in the aerospace application, the field test, what we call it as the launches for the launch vehicles, and the development launches for the missiles, whatever we develop. And we do the development launches, maybe 1, 2, 3, and we learn from each launch and do the improvement and incorporate them in the subsequent launch. By the end of development, you are ready with the frozen design and you are going to be ready for the transfer of technology for a useful system. That is, useful systems will be made ready and which are ready for deployment. Then phase E is operation and sustainment. That is the phase where you have the systems being developed, they enter into the usage. In case of launch vehicles like PSLV, it becomes a operational vehicle, and operational vehicle you keep launching them periodically. And in case of missiles, they become operational missile. Maybe the user may be doing the user trials, or in real war scenario you may have to use it, and you may have to maintain life support system also you'll have to do for its entire life, maybe 10 years or 15 years, based on the sensitive, life sensitive elements which are present in the system. And then finally we'll enter into the closeout stage where you have to withdraw the system from the what do you call field, and perhaps a newer technology may come by the time and new variants may enter into the scenario. This is the overall life cycle of the project. And then the system engineering engine, what we call, it is a module, one engine, and integration of all many such engines will become the overall system management. So if you look at the engine, you can see on the left hand side system design processes, and the right hand side system realization processes. These two processes, they become the project execution processes, and in between process, technical management processes, they are the processes which will monitor and guideline and give approvals and review them at various stages. And each engine, a module of engine, as you look at it, it takes the design input from the upper layer, you can see, takes the design input from the upper layer and it gives the design input to the lower layer. That is, specifications, requirements, they flow from top to the bottom. Whereas the realization part is concerned, it flows from the bottom to the top. The lowest level component will be made that enters into this, perhaps get integrated here and tested and evaluated, and main system will come out here. So components, that is realization, will follow from bottom to the top. And both of them, they interact, they get interacted with the technical management process. The basic advantage of the system engineering approach is you have to take the right approach or right solution right at the beginning, that is conceptual stage and design stage, and you have to do a thorough study and give a solution which is optimum. That is, as you go into the project, by the time you complete the design, perhaps 15% of the cost would have been consumed, but by the time you complete the design, 90% of the cost will be committed. You can see here, almost 75% is committed here and 90% is committed during development stage. Then doing any change at later stage becomes, it becomes very costly. So the actually selecting the best alternative, you should do at mostly conceptual and design stage itself, and once you enter into the development, better not to go for any changes unless it is really a mistake has been done or it is warranted. Definitely, it will cause you a lot of cost implication as well as schedule implication. That is what this figure shows. The system engineering approach will take care of it once you have a overall view, a bird's eye view from the top, and look at the overall system and look for the best alternative at the system level. Now if you go the way in which we handle the projects at our DRDO, you can see the user requirements. They are the basic inputs, whatever I said, stakeholders' expectations. From there, we have to come down to make a concept and then make the preliminary design and enter into the development. And then after doing the development, once the development is proven, go into the production, make the numbers and deploy them and maintain them, and then retire them when their life is over. On the right hand side, if you see, these right hand side activities, they are nothing but the technical management processes, which we do lot of reviews at various stages. And each review, whatever we do, we acquire a lot of lessons learned. And this lessons learned is a big database what the organization stores, and it represents the wisdom of the organization, and this wisdom will enter into every stage of the life cycle of the product development or system development. And you can look at the left hand side, design control, parts control, tooling control, process control, testing and evaluation. These are the various processes at different stages we undergo. And this is where I have shown the overall way in which we handle the project. And as I already said, the user requirements will be mapped first, and they will be taken here, and they will enter into the conceptual design, and specification configuration will be made. And from the configuration, it will come down to the system definition, and then design and preliminary the parts fabrication, and then you will enter into the testing and evaluation. And this is the integration. All the subsystems get integrated, and we do a system level test and the test and evaluation, whatever I said, the flight test, and finally developmental and flight test, and then we go for production and deployment. And as I said, the left hand side, this is the specification data, requirements data, which have been mapped from the users' expectations, and they have been converted into the design requirements at various stages. And all those data and design requirements, they'll become the data management, and you have to create the documents, and those documents will become the guiding documents for at every stage for doing that particular stage. And on the right hand side, you have all the monitoring mechanisms, review mechanisms, and every stage you have a thorough review, independent review, and then whatever the review guidelines or recommendations given, finally the review mechanism should approve that particular stage for going to the next stage. And even the testing and evaluation, whatever we do at every stage, maybe part level, subsystem level, system level, those data also will be reviewed by many standing committees, many various standing committees, and those review data will enter into the improvement. Sometimes they may call for improvements, and those improvements will be done, so that the final system, whatever you get, you have to get the best system, and you should not enter into any troubles at a later stage. And all the troubles you have to close at very, very early level. That is the motto of system engineering approach. And the same thing I have shown in a more detailed way. In the design phase, the system engineering approach during design phase, especially the design reviews becomes very critical. Once we formulate the user expectation into the design requirements, preliminary design and the critical design, and making a prototype, and then giving what do you call the design requirements and specifications for all the later subsystems and components, it has to be done in a comprehensive manner. That is the what do you call the level of involvement of system engineering approach. And the configuration control plays very vital role here. The configuration, because as you evolve, the configuration gets enriched. It keeps on changing, many updates may come, iterative way, the final configuration will come out. You have to keep the right traceability of the drawing and right traceability of the components, and you have to ensure that the user's requirement should be mapped all through mapping, whether it is done or not, that should be ensured. And during development phase, the main important criteria as shown here, the design validation tests. The design validation tests, they become very critical. You have to have design validation tests right from the component level, subsystem level, system level. The various types of tests what we do for a missile system, I have given the list, right from internal test to structural load test, environmental test, and 6DOF simulation, and a lot of functional tests like separation test we do, and many other tests, and kinetic heating test. Many tests will be specific to a particular project requirement, and all the tests must be listed right at the beginning, and we must make a plan, and these tests must be completed at respective stage, so that they will give the confidence that we are going in the right way. And all the test plans and test results must be reviewed properly by the independent committees. Now this is next level. If you come to the production and deployment phase. Production and deployment phase, the main importance will be the documentation. So whatever the design you have frozen by the developmental activity and completed your developmental test, all the designs will be frozen, specifications will be frozen, and test methodologies will be frozen, acceptance criteria will be frozen. The frozen things should enter into the documentation, well-defined documentation, and perhaps you may have to identify a what do you call a proper or qualified industry who can take up this and transfer the technology. All these things will come, and they will also be part of system engineering approach. They should also be, that is a mind process, a thought process has to be put on all these issues right at the beginning of the project. and system engineering approach for design development of the software. So if you look at it, as I said, the missile system will have a lot of intelligent units put on the missile system, and each intelligent unit will have its own onboard software, and you have a lot of ground support software which does the test and evaluation, which controls the launch scenario and takes the decision before launch, etc. And all these softwares also, we have to follow the system engineering right from the requirements level. You look at it right from requirement level, code design, implementation phase, and testing and IVI, independent verification, and delivery for the deployment. And you need to follow the standards and as well as the review mechanisms. On the right hand side, I have shown the technical process, like technical management process specific to the software with respect to reviewing and testing and evaluating the software at different stages. Then I want to highlight you what is the importance of the quality system in the missiles, and how the system engineering approach will give the best quality. So that is also very important. Now if you look at the definition of quality system, the classical definition of what do you call a quality system, take it as a gate for go, no go approach, it doesn't work. So generally, we take it as a quality system, inspect, and if it gets cleared within the specification, clear it. If it is out of specification, reject it. That is not the quality system. And quality system for missile systems, especially aerospace, or any other general engineering also, you have to look for getting perfect component. That is, incorporating the perfection in this system should be the approach of the quality management system. And zero defect culture should be the final culture, which will give the Six Sigma capability for any product or design. So how do you get this Six Sigma capability? One is risk mitigation. You have to prevent the defect. Preventing the defect is, unless you do a design for quality or design for Six Sigma right at the beginning, and all the weak areas you identify and strengthen them, then you have to mitigate them right at the beginning, then your quality will not be perfect. And use the right skills and quality tools to the best practices to deliver the excellent product. Whatever the processes you are using, tools you are using, they should be the best tools and the right tools with the right approach. And think in a system approach. As I already said, you have to think in a system approach, cross-functional collaboration to achieve the effective and efficient workflow should happen. And as I already said, learning from every stage is very important. Learning continuously to make the product and services and process more closer to the perfection. Perfection will not come in one day. You may be today, when you start the work, you may have certain variation, but you measure the variation, you find out what are the reasons for the variation, and try to close the variations, that is reasons. Then tomorrow you may become more closer to the perfection, but as you go on the roadmap, maybe at the end of certain days or certain time, end of the time, you may become very close to the perfection. So that should be your approach. And as I said, quality is not a gate for fitness, it is a means for perfection. And aerospace quality, suppose general engineering quality versus aerospace quality, if you see, what is the difference? Aerospace quality, you will stand totally on a different platform. I think that we should really understand. The aerospace quality, there are a lot of challenges. The challenges I have shown you, the lightweight is the major challenge. Any aerospace system, unless you make it lightweight, it will not fly. You can make a lathe machine with a good factor of safety, but similar factor of safeties if you follow for making a rocket motor casing of a missile or launch vehicle, it doesn't fly. So lightweight is very essential, And secondly, the missile system, aerospace systems, they'll see a lot of harsh environment and a lot of complex systems, and each complex system will be critical, and a failure of one system will lead to catastrophic failure of the entire system. So the failure cannot happen even in a single system. So if you look at all these things, the harsh environment, complex systems, critical functions, and significant its failure will demand that design should be robust. Design has to be robust, no doubt, but at the same time, if you look at the left hand side, the lightweight demands that you have to use very high specific strength materials, that is the materials which will never be used in general engineering, like titanium, maraging steel, high strength carbon composites, they will enter into the missile systems, whereas you don't find them in general engineering. And also, not only that you are using very high strength material, you operate them at optimum factor of safety. You cannot afford to have a factor of safety with what we follow in general engineering practices. If you make a boiler pressure vessel code says a factor of safety of 3 on yield, 5 on UTS. But a rocket motor casing, which is also a pressure vessel, if you follow the same thing, it doesn't fly. So the factor of safety here is 1.12 against 3 on yield, and 1.25 against 5 on UTS. Such very close factor of safeties we follow. So that makes the scenario, you want robust and you need to have very close factor of safeties, high strength materials you use. Thereby, it becomes very, very complex, and the requirements will go up like very stringent. Unless you follow what you call a system engineering approach and consistent efforts if you put, you cannot really get the best quality. And all the stakeholders who are involved in the what you call the quality system and processes, they should work together to give the best quality. So teamwork is very essential. Isolation, if you work, you don't get them. And here you can see the system engineering processes, they are mapped for all the AS 9100 quality management system, and every system engineering process is mapped against the requirement of AS 9100, so that the system engineering gets integrated with the quality management system. And even if you look at it, the way in which the quality management system evolves in its life cycle, the Deming cycle, you can see PDCA, plan, do, check, and analyze. So this has to be done even for improving the quality system. So the Phillips Crosby it gives, the quality management system will go through many stages, from uncertainty, awakening, enlightenment, wisdom to certainty. But you cannot go on its own unless you do learn from every step, enter into a higher level. You cannot reach to the metrics which are needed for the certainty. And the reliability study also, it has to be mapped along with the total life cycle of the project, and at every stage, whatever the particular reliability activity which need to be done, they have to be done online, and reliability has to be built into the design. Then I thought I will give you only, I think 5 more minutes I will take, and 4 case studies which are very important to show the system engineering approach, how it plays a role. And all of you must have heard the great space shuttle failure. Space shuttle which has been designed and developed and entered into the operation. Finally, in 1986, the space shuttle, actually, it bursted and leading to the death of many civilians. And if you look into the cause for the failure, the cause were given by the actual rocket motor casing, the O-ring design. If you look at it, they have provided 2 O-rings, and as the rocket motor gets pressurized, it dilates, motor dilates, the joint opens, and the redundant O-ring, it becomes ineffective in this particular design, and the primary O-ring has to take the entire the safety aspect, and the redundancy doesn't really work. And as the temperature varies, it goes to the lower temperature, the compressibility of the O-ring will keep on coming down. And in many launches they have seen the gas coming out, but it never led to any failure, and the management has taken a decision, okay, it's a working design. Though on 1986 when they did the launch, the temperature went into the least, and the first primary O-ring also, it became brittle and it could not really do effective sealing. That is how the leakage has happened and led to the failure. And actually, a design failure in operational system is a really big failure for the system engineering approach, is a big failure for the management. So that way, the taking into the design requirements, mapping them for the overall temperature requirements, and then doing the thorough design and testing and evaluation, and it is really missing for this particular design. And also the management was a bit complacent to take a right decision, though they have seen the leakages which are not causing the failure. They should have taken the corrective action right at the first flight itself. When small leak was there at a given temperature, they should have imagined at lower temperature the leak could have been more. This is 2003. The Space Shuttle Columbia collapsed, and this is where our Kalpana Chawla gave her life. And here the failure is on the liquid engine, liquid oxygen, liquid hydrogen. When they are stored in the tanks, they will be cooled with foam, and they call something like foam shedding. As the launch takes place, the foam pieces will keep coming out, and because of the bond integrity problem, and they have seen small pieces coming out, but in this particular day, a large big piece has come out, and that has hit the rocket motor, which led to failure. So it is only something like system engineering problem with respect to the process design, process control, and inadequate entity testing. Once you do the adequate entity testing, this bonding integrity or lacuna you would have identified. This is another case, the rocket motor, which is designed with a high strength managing steel. The design has been proven, and we have done number of tests, and finally one of the operational motor, it has failed at lower pressure. And when we really analyze what has really happened, the failure was not classical. Classical failure supposed to be along the longitudinal joint it should fail, whereas this fellow failed during along the circumferential joint. And when we have analyzed, we have found that there is an inclusion, non-metallic inclusion, aligned at that particular location. So that gives the system engineering has to be mapped even at the chain, that is supply chain management also. The person who gives the forgings to you, his process also you have to look into that, and we have to control, and we have to add adequate test to see that such problems are not there. And this is another failure, United Airlines flight 232 crashing, and 111 people died, and there are 3 engines here, and on the particular day that 2 tail mounted and 1 here, 1 more engine. This engine has blasted, the titanium rotor which was there in that, it has cracked and became into pieces, and that led to the failure. And they could retrieve this particular titanium rotor, and I have seen the crack initiated at one of the inclusion, and then the crack was growing. There are 2 problems. One is with respect to life of the system, we have to see what is the best melting process. So they have recommended finally triple vacuum melting, which is very essential. And secondly, the periodic testing, whatever they do, NDT, that should be foolproof test. So all these points, system engineering should foresee right at the design of the program system. And with this, I am closing. Thank you very much.
So thank you so much, Dr. Babu, and we don't have time to ask questions, but if you have questions, you can certainly let him know. So I would like to invite Professor Jenamani to give him a small token of gratitude. So Professor Jenamani, please. And this was a very exciting presentation, at least for me, because we teach project management, systems engineering, quality engineering in our department all the time. So we got to see that how it is actually used for the development of missiles. So this is truly an industrial engineering presentation for that matter. So thank you, sir. So next I would like to ask Professor Akhilesh Kumar to introduce Dr. Bharat Bhushan, our next keynote speaker. So yes.
Good afternoon, everyone. I hope you are enjoying the sessions, and I'm sorry I'm between you and the lunch, but last keynote for today on topic Factory of Future Application of Industrial Engineering and Digital Technologies in the Manufacturing Sector. I'm very pleased to introduce Dr. Bharat Bhushan. Dr. Bharat Bhushan brings in more than 25 years of experience in manufacturing and digital transformation. Currently, he is working as Vice President, Projects, Engineering and Technology. He is also Chief Information Officer at Tata Steel Downstream Products Limited, earlier known as Tata Metallics. Prior to this, he has been associated with leading companies like Tata Steel, Tata Metallics, EY, Hatch, Vedanta, and TCE in senior leadership position in India, UK, USA, Canada, China, and Australia. He is a visiting faculty at XLRI Jamshedpur and IIM Sambalpur. Bharat has also authored a book titled Data Driven Techniques for Advanced Process Monitoring. He is a gold medalist from Indian Institute of Science, Bangalore, and Indian Institute of Management, Ranchi, and has also completed his PhD in Advanced Data Analytics from University of Sydney. And more importantly, I had pleasure to work with Dr. Bhushan during one of the projects with Tata Sons and Department of Heavy Industry. We closely worked and developed an interesting, predictive maintenance solution. So I welcome Dr. Bhushan to the dais.
Good afternoon, everyone. First of all, thank you, Dr. Akhilesh Kumar, for a very nice introduction. It's a privilege to be here. Thank you, Professor Jiramani, Professor Mathi, Dr. Rai Chaudhary, to invite me here and talk to you, talk about what industry, from industry perspective, what we are looking for in near future. So as Dr. Kumar mentioned, I think, after him I am standing between you and the lunch. So I will try to finish it within 30 minutes. I think, it's very important to look from what and where we are moving from industry perspective. Because, tomorrow many of you might be bachelor student, master student, or even researcher, so you would be going to industry. So it will be really good to discuss some of the aspects of the requirement which the current industry are focusing towards. Also from research perspective, especially we have very close tie-up with academic institutions, and we work very closely because, the cost of having a very dedicated R&D center or innovation center is something, may not be affordable to medium and small size companies. So I think the opportunity of research, especially in coming decades, we would like to touch upon that. And then we will see, like in the end, what exactly, some of the areas, what are the challenges which industry is facing, both in terms of technology and also the people, because that is one very important factor for the industry. So I think, there are two core, in fact, I'll go back to this, the title which was there, that was very long. So I curtailed it and then thought, let's focus on two core disciplines. One is industrial engineering, and the second is, which is growing and developing and has moved in last 10 years drastically, is digital. How it's affecting the manufacturing industry and how it's leading towards factory of future, right? So across the globe, if we see, the manufacturer in the last 50 years has been implementing a lot of programs and techniques. Many of that you might have gone through, being from industrial engineering, for example, Lean, TQM, total quality management, TPM, total productive maintenance, Six Sigma, all that, it has given a very solid, yielded a solid result to the companies. So you must have heard about Toyota and companies like Procter & Gamble. So they have even improved their productivity year on year by more than 6%. Okay, so this investment in this kind of techniques or programs are not obsolete yet. In fact, that is basically giving the foundation. It's basically setting up the foundation to do something on top of that, right? But is that enough? I think in the current scenario, if we are looking for, having efficient facility of future, I think there are more to be done, right? And the two critical development which has happened and raised the bar for manufacturer to plan for their future of factory strategy, a factory of future strategy. One is digital technology, that is the opportunity. It has completely set a new, in fact, Professor, you must have gone through the presentation by Professor Manoj Kumar Tiwari. He had talked about a lot of digital technology. It has raised the bar of what the new generation facilities are going to be. Okay, so the digital technology in totality can basically impact your productivity, as reported by companies like Bain, BCG, can improve your productivity by more than 10%, right? That's a huge kind of thing for sustainability. Now the second aspect is what is, coming up more from the challenge perspective. If we look from the challenge perspective, sustainability is one of the very key aspects. All the industry are, the stakeholders, whether it's customer, whether it's employees, whether it's the regulatory bodies, they all are looking towards the industry to, have a very marked improvement in the KPIs related to decarbonization, circularity and all, right? So I think, it's very important for companies, to club the opportunity along with the challenge and not only work on the superficial level, like, the siloed solution. What we call is doing digital just for doing it and having the point solution, but rather focus on integrating what is in there into the system. We talked about Lean, Six Sigma, TPM, TQM, with a very robust approach of, bringing the two together to have an innovative supply chain and the production. So if we look at, the future, so the future, is going to be a integrated and connected operation, okay? And what are we going to look at? So I think, see, what has happened in last 10 years is if we see the improvement, is the cost of data, right? Whether it's data acquisition, for example, the cost of mobile, when we use the mobile, if you remember, some of us who are basically, like 20, 30 years earlier, the cost of calling or, the memory which was used was like 100, 200, 1,000 times more, right? So the cost of the data acquisition, data storage, data processing, data communication, all that has gone drastically down. At the same time, the cost of the sensors, for example, if you, some of you, like Dr. Babu, can remember the cost of the sensors used to be like 1,000 times more. Now you can have a vibration sensor as cheaper as 5,000, 10,000 rupees, which was not there. It was only being used in very, like critical industry, for example, like, DRDO and those places. Now those are easily available and can be used to connect the operation, right? So the production is going to be connected. We are not going to have independent siloed operation. Everything, whether it's related to operation, whether it's related to maintenance, whether it is related to quality, people are asking for a unified platform. All the data, everything should be available for the manager or the operator to take the decision, right? Similarly with supply chain. If you now go, I think many of you might have seen, like, the Ola and Uber kind of operations are coming in supply chain of industry as well. So everybody asks, our customer asks to know where the consignment are, because, they plan on that basis their production. So the connected supply chain are going to be there, and, many companies have already started working on that. Connected customer, like, it's all, you must have heard of CRM, customer relationship management platform, where you really don't have, customer doesn't have to talk to you, they can go, like we do it on Amazon, right? So that is one way of e-commerce thing, which is basically connecting customer directly with the product. There is no mediator in between, right? So similar things will come into the industry as well, okay? So customers should know end to end whether the product which they had been looking for has started, like, you must have seen in Pizza Hut or KFC. They always give you the update so that you feel happy, right? That, okay, now it's in the oven, now it's coming out of the oven, now it's in the way, so you can plan, your home, putting the things, water, everything to eat it, right? Similarly, in industry, the customer is asking for that. As I said, inventory cost, as being an industrial engineer, all of you know, it's one of the biggest challenge. That is, the working capital, which is getting stuck, because if I don't have visibility, I'll be keeping a stock at my end, my customer will be keeping a stock at their end. So these are the avenue through which we can reduce the cost, right? Connected people, employees. Now everybody wants to know, they don't want to go to, we don't want to have the big HR office and people coming and asking about the information. They would always like to know what is happening. And not only that, even to know how my industry is doing in terms of sustainability, on water consumption, on people are becoming much and more aware. So how we can connect people with the whole operation, right? And then very important, the connected supplier. So suppliers are going to be there. They are going to be the backbone of our operation. They are going to basically provide all the raw materials which you need. So again, to make sure that you have the lean manufacturing, you would need to be connected with your supplier. But to do that, you need a lot of capabilities, which is not there or may not be there in industry at this moment of time, right? For example, cross-domain expertise. That is a capability. Now, gone are the days when we used to have very isolated, people who will do only part of the job. Now the requirement is, it's kind of, you need to know a couple of things. I'm not sure how many of you have gone to the interview for job in industry, but now asking the candidate whether you know Python or not is a very common thing, right? So Python is no more a requirement, learning something which is new. It has become a hygiene factor, right? So similar kind of thing. So you may be a very good industrial engineer, but you need to be getting, accustomed, knowing what is happening and how I can grab those kind of knowledge which are very easily available now. In fact, for many of the courses, you don't have to pay anything, right? Circular economy, and that is very important, there are going to be a lot of focus in industry on circularity, decarbonization. So people who should have knowledge about how to recycle, how to reuse, how to remanufacture the things. Digital, as we spoke about, I think it is going to come. I think, you know, the kind of momentum which it has, and as Dr. Akhilesh Kumar and Dr. Kishan Kumar is there. In fact, our first project together was on digital, you know, like health monitoring, which is still running in Tata Metallics, thanks to them. We did something which was not easily available into the market, right? And that's where the value comes, when, you know, we work together with industry work together with academia and research, right? And additive manufacturing, you know. So again, you know, we are maybe 3D printing, that is one of the core components of additive manufacturing. Very small components just for maybe a spare and all. But, you know, who knows, maybe after some time, you know, Dr. Babu maybe, you know, like would say, I saw a video wherein, you know, the whole rocket bottom part was getting 3D printed, you know. A company from UK was doing that. So I think, you know, then there is no need for the manufacturing unit to be there somewhere located at one place, you know. You can have mobile manufacturing unit moving along with the requirement of the customer. I mean, of course, that will take time, right? If we look at the trends, right, now again, personalized product, you know, we can go and choose, if you go to some of these, you know, e-commerce platform, you can choose what do you want to be printed in there, you know, like what are the color, what is the color you want, so what is the size, you know. Earlier it used to come in a standard size, but it's not only applicable to clothing, you know. Our customer, which is more steel, iron, which used to be considered as a rugged kind of industry, they are also asking a very personalized product. I want only this much thickness. I want only this much of width, you know, with a precision value of 0.1 mm, those kind of thing, right? Infrastructure has to be going to be flexible. People are thinking of, you know, like mobile robots. How can I reduce the safety issues by having a flexible infrastructure, right? Servicification. Now it's not only about selling the product. We always talk about how, you know, like we can provide end-to-end support and services, right? So this is again from BCG. You can see the kind of impact, you know, the digital technology and industrial engineering together can bring on the conversion cost. Conversion cost is one of the biggest cost in the industry, you must be knowing. So approximately, you know, if you do a right investment, you know, in 10 years time, you can reduce your conversion cost up to 40%. I mean, which is a huge number. This is what is required to sustain the business, right? Same with manufacturing cost. Manufacturing cost can go down to, you know, up to 20%, okay? And apart from that, this kind of technology, when we talk about digital technology, some of that we will see in the coming slides. It can give you flexibility, it can give you better quality, you can have the product much faster, we can have a lot of safer operations, right? And if we look at the investment, that is not that high if we look in long term, right? So over a period of 10 years, if you are investing in tune of like, you know, 20% of your EBITDA, and I'm talking of over 10 years, not every year you are investing that. You are, if not 40%, maybe getting 30%, 20%, depending on your operation. That is a huge impact. And only the company who will embark on this kind of thing in a very systematic way will be able to gain that, okay? Otherwise, you will be out of the business, okay? Now, there are going to be focus. There are going to be focus area. You know, there had been earlier, mostly people used to talk about how profitable is my business, how much EBITDA I am making, right? The focus was on how much revenue I am generating. But now, slowly, you know, the focus is going to change or is changing already. Focus is going to be on safety, sustainability, productivity, and profitability. Of course, profitability is there. You know, we need to have our business profitable, otherwise, you know, we won't be able to sustain. And what are the enablers? You know, enablers can be technology. So now, you know, if we look at the ecosystem, many of you, you know, already know, like, you know, there are incubation center in IIT, ISC, and those kind of places. So there has to be an ecosystem built around that. Easy solution can be developed, but there are still going to be something which is going to be breakthrough, not only the continuous improvement. That has to come through innovative solution, wherein there has to be some research and development, the opportunity for IITs and others, IC to work together with industry. So there are opportunity of innovation. There are opportunity for entrepreneurship. Many of you must have, this is a very common trend. And there is opportunity, we are working with at least 5 to 10 startups, right, in our organization. So people coming with, very young, bright people with very lot of energy, because that is what they bring a lot, lot of energy with lot of new idea, and they try to solve the industry problem, right? So, safety, these are certainly no way it's an exhaustive list. There are a lot of other components. We have just put something which are, we felt is important and critical, like, robotics automation is one of the area which is certainly going to pick up. In fact, we have put up a proposal from Department of Mechanical Engineering together with Department of Heavy Industry, how to reduce the man-machine interface in one of the operation at Tata Metallics, wherein the people, clean some of the things, hot metal, many of you must be knowing it's at 14 and 1500 degrees Celsius, right? We don't want to be next to that. But that was the traditional way of doing the things, because there was no technology. Now we are looking for technology, how to use robot or automation system to reduce that, man-machine interface. AI-based video analytics, like, how we ensure that people should not go to the area, like, the rotating equipment and all. In fact, we did one project with one of the master student of Professor Giramani, on basically on the shop floor, there is a moving, trolley. So how if somebody comes near to that trolley should automatically stop, right? Based on video analytics. Sustainability, I think, it's very important that we should have track and trace of end to end of our, raw material product, how it is happening, and how the flow is happening, so that we can optimize. In fact, Professor Tiwari spoke about some of those optimization use cases, right? And then combining, lean, digital, and sustainability into a future-oriented network using IT/OT. So how IT, information technology, can integrate with operational technology, and we can use that for, have clear visibility on our, consumption of the carbon and water and other things, right? So the opportunity, are there in terms of decarbonization. Many of you must have heard, green hydrogen, especially in a steel plant. That is one focus area, because, carbon is one of the main reasons for greenhouse gas. So a lot of research is happening. In fact, you just search for green hydrogen in a steel industry. There are like thousands of projects, either consultancy, research, or, the company on their own are working on that. Circularity, as we spoke about, how to reuse the things. For example, I would like to cite, in fact, since we do something, I would give you example so that you can correlate it. We are working on 3 projects with ISC. So we used to generate a lot of slag. Slag is nothing but, the waste when you convert iron ore into hot metal. So how to replace the sand using slag in some of the coatings, right? That is kind of, circularity, so that we can use our waste product, which generally used to go to, dumping, and some part go to cement plant, can be used for that purposes, right? Similarly, we had been working on some of the, and the slurry, which is certainly a waste product, which goes and gets dumped into the land, creates a lot of problem, because if you put the slag, then you won't, slurry, nothing will come on, the biodiversity gets impacted because of that. So how to, use those slurry to basically make bricks or something similar kind of product which can be used in this one. So I think we certainly, there is a desire from the industry, and I think, the research institution and academia are also coming forward. A lot of these projects are moving forward pretty well. When we look at productivity, it's a big gamut. You know, if you look end to end, you need, you know, people are looking in digital side on connected operation. As I mentioned, everything end to end visibility is there. Predictive maintenance, like I mentioned about the use case which we work together with Dr. Kumar. How to predict the health of the machine in advance, so that you know you can take a planned decision on stopping it with right time. And then profitability has all gamuts of customer, you know, planning and scheduling, inventory management and all, because that gives you the buck to run the business, right? And as we spoke about, you know, if we look from, this is again completely thought based on our interaction with different startups and all, that, you know, there is a huge opportunity of entrepreneurship. So some of you are thinking in that area, especially in sustainability and, you know, the area of profitability. And, you know, if we look at sustainability and productivity, there are still a huge gap, you know. So there could be project wherein, you know, people can work together within, you know, academia and, you know, develop the solution, which cannot be done through day-to-day, you know, normal startups or the, you know, companies which are in there. So again, digital, we spoke, you know, because we talked about the normal traditional approaches, conventional approaches of lean and all. But digital has to have, you know, it should be intervened at all the levels, including a strategy, technology, people, and then there are going to be benefit out of that. So at a strategy level, now it's almost in agenda of all the CEOs, you know, everybody, at least, you know, 60–70% of the company. Earlier it used to be only, you know, point solution, I'm doing digital for the sake of doing it, because it was a big buzzword, but now it's talked as part of annual business plan and all. It certainly support customer centricity. You are much closer to your customer, what he is looking for, what is his demand, you know, you can support that. From technology point of view, we, you know, in previous sessions, there had been a lot of discussion around that. But, you know, there are a lot of technology which are coming up. I will quickly touch upon those technology in my next slide. I think what is very important is people, right? So the whole ecosystem requirement of running a plant is changing, okay? So as I mentioned, you know, we do have, you know, especially traditional manufacturing plant, you will see a lot of people who are, you know, in the age bracket of 45, 50, and had been used to do the job in a very traditional way. This is a big change for that, right? This is a big challenge which need to be addressed, okay? And the benefit, as I mentioned, you know, it's a no-brainer. I think, you know, if it is done systematically, I think the key word here is systematic. It should not be, you know, at a point solution level and all. If it is part of a strategy, if we plan it properly, there is certainly going to be huge benefit out of that. Not sure about time, but let me quickly, in a minute or two, tell you about how the whole, you know, the system, if you are looking for a really good digital infrastructure or digital drive in your organization, how it is going to be. So you need to integrate your OT system, which is operation technology, with IT system and with digital systems. And in industry, we call it level 0, level 1, level 2, level 3, 4, 5, right? So level 0, 1, and level 2 is more like, you know, if you all must be aware of control systems, right? So if I'm putting the sensors, that is level 0, okay? If there is a PLC, programming logic controller, or DCS control system, that is level 1. If there is a, you know, physics-based model, right? We call it level 2 automation system. Level 3 now gets more into IT systems, right? So you have MES, manufacturing execution system, must be aware of that, production planning and scheduling system. So if, you know, the bottom part is not robust enough, the chances of success is low as you move upwards, right? Level 4 is, you know, ERP system, SAP and all, you might have heard about it, right? Business and logistic management system. And level 5 is what we are talking here. So you need to have a very robust level 0 to level 4. Of course, I'm not saying that you finish very well up to level 4, but you need to have some fundamental infrastructure at your OT and IT end to get the benefit out of the digital technologies such as big data analytics, ML, AI, cloud computing, robotics, RP, and so on. And basically, that is where you put something called data lake, data warehouse, wherein you have data from different sources so that you can put your advanced model on top of that, right? So if you are going through the courses, I think this will really help you. Think about this from this perspective, how the things are there, you know, and there are requirements, there are engineers like instrumentation and control engineers, a lot of them are from industrial engineering or instrumentation and control engineering. They work in level 0, level 1. Level 2 is more, you know, we have seen the current trend is more metallurgists who can develop the models for a steel plant. Those are the people, but still, you know, a lot of things happens in there. Level 3, level 4 are, you know, it's a mix of both. And level 5 is certainly, you know, something which is coming up and helps the industry a lot. So where are we, you know, if I look from the industry perspective, I have put like 9 major digital technology. Mathematical modeling and simulation, I think we all will agree it's almost mature. We always talk about past, present, and future, right? So the past, you know, it had been there for a very long time, you know. We used to do that when 28 years back, I was doing my master's, and we used to run the program in Fortran. रात में चलाते थे, फिर सुबह आते थे, पता चला उसमें error है, तो फिर से चला रहे हैं, right? So you guys have not seen those days, but it has been there for a very long time, right? Same with level 2 automation system had been there. Now coming the interesting one, AI ML, it's still picking up. I mean, we are doing something in industry, but I think it will take some time and the reason behind that is understanding is one aspect, but the second aspect is infra, which I was referring to in the previous slide, right? IIoT, again, lot of sensorization, needs lot of focus from the industry, industrial Internet of Things. Big data, cloud computing, in fact, IIoT, big data, cloud computing in the manufacturing sector goes hand in hand. So they are more or less at the level wherein you can, you know, think of your next 20, 25 years of career. It's not going to go away. There is still a lot of work to be done. Same with robotics, you know, we are doing a lot of trial and error, but I think, you know, a systematic way, except automotive plant like Tata Motors and all, or Toyota plant, if you will go, you will see 800, 900 robots. But it still have to be, you know, used to a good scale in other similar industry. Digital twin is coming up, but not in the model which basically should be there. It will take time because if we look at the real digital twin, you really need a lot of physics and mathematics behind that to really depict what is going to happen in your actual environment. Okay. Now, so we spoke about technology. Don't worry, this is the second last slide. If I'm okay, my memory is good. So there are a lot of issues with, you know, opportunity from perspective of finding out the right qualified employees. Again, this is a report by PwC, you know, like, and they do the survey. In fact, we believe a lot on the consultant, you know. Many times they are not right, but we don't have any option, right? So they have done a lot of survey and they have found that 80%, 81% of the CEOs, they had been saying that they are finding difficulty in finding the right qualified people who can, you know, help them building and running this factory of future, right? With lot of optimization, lot of, you know, like making sure that the things are keeping in mind the sustainability and those aspects. There are large investment in training for the employees which are there. In fact, for working together with technology and people working together with that is yet to come up. You know, in fact, there was one study from Japan which says, in fact, many times the mindset of the people is, you know, if I'm going to put a digital technology, people who are, you know, like 10 or 12 years of retirement age, before that, they're going to lose the job. In fact, it's other way around. That a study was that now the machines will be there doing the job. These people, because of their experience, can continue working longer. But then you have to have that kind of setup, right? We are still far away from that. Because, you know, not in India, we don't have that problem much, but in other countries like Japan, European countries especially, there is an issue with the aging population, right? So there are a lot of people who are aging and not many people are there to work. So they are looking in Germany and Japan from that perspective, right? How I can use Industry 4.0 and digital to support my older employees not to retire at an early age, right? But that needs again a lot of investment and a lot of work around, you know, training the people, right? Again, you know, present training in school, I think it's not very, again, this is a study, so excuse me for that, but, you know, I think, you know, there has to be a curriculum built around the requirement in the industry to support, you know, what the industry is looking for. We do have started seeing people, you know, on their own coming, they know Python, they go to Udemy or they go to Coursera, LinkedIn, they learn it, and that is very good sign. I think if it can be included in the curriculum, it will be really helpful. So some of the, you know, thought around, you know, this is digital technology. It is going to be, you know, the backbone, if not now in 5 to 10 years in manufacturing industry. But it is diffusing fast in high-tech industry. But if we look at manufacturing industry, it's not being, you know, it's being implemented cautiously. And in fact, if we look at the positive side of the coin here, that means there are a lot of opportunity in there, right? Digital technology had been bringing, you know, like incremental improvement, but still breakthrough improvements like the one which we were talking, using 3D, you know. If I am like, you know, sometime when we used to catch up with Dr. Kumar, we used to think, and in fact, our plant people used to say, why can't we, you know, plant to 3D print the pipe, you know? Why do we need the pipe to be manufactured with a lot of infrastructure and all? So those will be breakthrough technology. It will come because, you know, whatever is there now, we had not envisaged 10, 15, 20 years back. So, you know, we cannot envisage what is going to happen. Only the movies can tell what is going to happen in the next 20 years, right? Because what was shown in movie 20 years back is more or less happening now. Then the multidisciplinary nature, right? We cannot be only focusing on the core discipline. Of course, core is very important when we are looking at the education of this one, but then the courses from, let's say, computer science or from other discipline will help a student. And as I said, there is an excellent opportunity for industry academia to work together. I think it needs much more a stronger handhold from both sides because, you know, in industry we say we are very impassionate, right? So we want result in 3-4 months, okay? Otherwise we think kaam ho nahi raha hai. We always used to call Dr. Kumar, he was very fast, let me be very frank, yeah. But, you know, like some of the project, because, you know, the research project may not be taking first priority because of other engagement and all. I think it's very important that, you know, some, you know, and that is how it's coming, like a lot of incubation center and others are coming. But I think with a very strong focus, there is a huge opportunity which is going to come in 10 to 15 years in this area, especially industrial, engineering, manufacturing sector combined with digital. So thank you very much.
So thank you, Dr. Bhushan. I would request Professor Akhilesh Kumar to present with a small token of gratitude to Dr. Bhushan.
Come. Thank you so much.
So today's keynote sessions is coming to an end here. So our track presentation sessions will be in the IAC department. So after lunch, you please go to the Department of Industrial and Systems Engineering, which is in the main academic campus. Okay. So our program here has ended for now. Thank you so much.